Good afternoon. Lovely to see you. Hope some of you have had a nice tram ride as well. The rest of us hopefully have had a nice wrap and discussion outside. We're going to have a lovely afternoon. Let me first introduce myself, and then Anders will introduce himself shortly, and then I will say a few words. My name is Mats Lundqvist, relatively new as Vice President of Utilization. I took on this project with Peter and Martina at the alumni coordination and a lot of people from E2, where Anders is the head of department, as a way of connecting with Chalmerists. And I'm so happy to see that many Chalmerists here. And I'm sure there are also some friends of Chalmers that are not Chalmerists. You're very welcome. So, before I go into a little bit about the day, Anders, tell us about yourself and your department a bit.
My name is Anders Karlström. I'm the head of the Department of Electrical Engineering. I'm very glad to see so many ambassadors here today, because all of you have a specific topic, I suppose, and you are also related to Chalmers in one way or another. Today, we are going to show you only a fraction of what we are doing at the department, but it is divided into 3 teams. I will not go into details about the teams, but I'm very proud to bring this up because next time, in the next 120 years, maybe we can show you more about our new robot technology, other issues which we are struggling with, and so on. I'm very glad that you are here, and we will looking forward to these presentations later on. Thank you.
Thank you, Anders. So let's see if we get yep, it's working. It's all about electro today. So this event started when an alumni, Björn Albrektsson, figured out that it's 120 years since the department started. So that's 1902, and some of you have seen the slideshow. We're thankful for that. He quickly joined with Bo Hedfors, an electro from what year, Bo? It's 68, who is a former Ericsson and Motorola, etc. executive, and they've been critical helping us in the team here at Chalmers. Primarily, the main person helping out with the program is Ola Karlsson. You will be introduced to him in a moment. So we've taken on this day together, not just because we love electro, but we do. We do this as a way of connecting in new ways with alumni, but also with faculty and with people that we collaborate with in industry. And one day we will also have even more students here. We were hoping they would be more, but we believe that will also happen. They are actually pretty busy in courses during Fridays, we learned. Surprise, surprise. So that's it, and we are not just super happy to have you here. We actually have around 130 more alumni on the YouTube channel, which is on now, sending. So this brings us to the day, which is like this. We will start panels in just after having presented a bit about the electro education. Then we will start the first panel, and as you know, there are 3 panels with a moderator of every panel. They will be allowed to introduce themselves, stand here and present a bit, and after that they will have a discussion moderated by the panel moderator. Anders and I, we will step up and interrupt 10 minutes before the ending of the session to allow you guys to ask questions. Martina has, and no, students we have help with that, to bring microphones up so every question here in the room can be heard, even on the YouTube channel. And then Martina is actually checking the YouTube channel for any questions that might be coming from the Americas or the Asians or whatever they might be. So you will come up with the very high-tech method of giving us a post-it, I think, and we will read the questions from the YouTube channel. Wow. So that's the setting. We want it to be Skavlan-like. That's why we have these chairs, so everyone will sit here, but they will introduce themselves 5 minutes each, and then we hope for a dialogue, and that will be intense. And then after at least 10 minutes, you can prepare if you have any questions. We really want this to be interactive. and that this spreads. So please talk about this. This is Chalmers for the future, connecting worldwide through these kind of events. So let's launch it by asking our Vice President for Education and Lifelong Learning, Jürgen Blennow, and the Electromass Program Manager, Jimmy Enberg, to enter the scene as well. And you guys have microphones.
Yes.
So with that, let's get the show started. Thank you.
Thank you. Thank you. It worked. I'm extremely happy to stand here in front of you and see so many electrical engineers. My name is Jürgen Blennow, and I am also quite new in my role as Vice President of Education and Lifelong Learning here at Chalmers. My background, what makes me even more proud to be here, is that I myself is an electrical engineer. I graduated from electrical engineering in 1993. I continued as a PhD student in high voltage engineering. I have been head of the 5-year engineering program, electrical engineering, for 9 years, and also Dean of Education for one of our education areas. And I will now try to, in mixed language mode, both Swedish and English, try to give you an overview how education looks today at a Chalmers level and how we are organized, because a lot has happened since you left Chalmers. And after that, I will give the word to Jimmy Enberg, who is now the present head of the 5-year program in electrical engineering. But as in many presentations like this, I start with organization diagrams, and we are engineers, and we like this kind of structured way of thinking. 2005, there was a major reorganization at Chalmers, and that the sektioner for electrotechnique, sektioner for maskinteknik, these were dissolved. And instead, Chalmers went over to a department organization. So today we have 13 departments at Chalmers. Quite big department compared to before. And we're working in a matrix. So we have the education in one matrix that is as a line that is orthogonal to the departments. And we also have what we call areas of advance also in the matrix, where we have the societal cross-disciplinary challenges gathered. So it's important to remember that the program of today does not belong to any department. It goes all over the program. We have a buying and selling organization when it comes to education. And for us, that means it will be a focus on the students' learning, not the department's need, but the students' need. We put the student in center. In 2004, as many other universities, Chalmers also went over to the Bologna model. And we got a 3+2 structure. So now we have a 5-year engineering program, but it is divided into 2 parts. Chalmers was one of the universities that made this the most consequent in the country. All our programs was divided into one bachelor part and a master's part. Still, as you see in this slide, the students are admitted to 5-year professional program. They are still admitted to a civilingenjörsprogram for 5 years. And then they follow the first 3 years. After these 3 years, they can select a master program that gives them the specialization. And when it comes to electrical engineering program, the students can choose between 13 different master programs and still get the professional civil engineer degree. They can also choose other master programs, but if they choose outside these 13 programs, then they will not be given a civilingenjörsexamen med inriktning elektroteknik. Then they will only have a bachelor degree and a master degree. We also have the 3-year engineering program, högskoleingenjör still. And those does not get a candidate examen, bachelor degree. They have also the possibility that after 3 years to select a master program. But then they will not get the 5-year professional degree, civilingenjörsexamen. And then you see that we have a bunch of students up here waiting eagerly to come to Chalmers. And that is our international students. On master level, all master programs are taught in English. And we have approximately 30% international students in the master program. And that helps us to, here in Gothenburg, to create an international environment. Some key figures to see, Chalmers has grown. The income to Chalmers, or the turnover when it comes to education, is more than 1 billion. We have, and you see the different degrees. What is important to note here is that we also have a master program that leads to a lärarexamen för gymnasiet, ämneslärarexamen in mathematics or chemistry. 1,446 master degrees. So our Swedish students, they will get 3 degrees. They will get a bachelor degree, master degree, and civilingenjör degree, if they fulfill all requirements. I guess when you were students at Chalmers, there were few but very big programs. Now we have very many programs. We have, this is one of 5 educational areas. We have one for the mechanical side, we have one for the civil engineering, and one chemistry, mathematics, and one lifelong learning. But this is electrical, computer, software, industrial management, and medical engineering. And here we have the civilingenjörsprogram in electroteknik. And we have here 5 master programs connected, but remember, as I said, the students can select between 13. We have computer engineering, software engineering, industrial management, and economy. And a quite new master program, a new 5-year program started 2020, medical engineering, which is a very attractive program. And then we have, in this area, we also have the 3-year program, högskoleingenjörsprogram. And these are located at the Lindholmen campus. So one way to look at this slide is that Electro has been expanded a lot. It's not one program anymore. We are also developing our learning environment, and our foundation has financed over 10 years. Our foundation has financed 200 million crowns to establish a new learning lab. And the reason for that is that we see that the education for the futures need to be flexible, individual. There is a high demand on professional skills, interdisciplinary knowledges, and to shorten the times that it takes to deliver the right competence for the society. Now the digitalization and electrification goes extremely fast, and we cannot work with time that it takes 7 years to adopt before we can graduate an engineer. Chalmers is also a sports university, ett riksidrottsuniversitet, where we try to enable students to combine sports with university studies. But we also have sports research here at Chalmers. And we are also working with Sahlgrenska Academy and something about internationalization. We try to be an international university, and we want all our students to have international experiences. We are working, as many universities, in European alliances. And here we have these three alliances. Chalmers are active, and we have managed to get quite good friends. We are working a lot to increase the number of female students on our programs, especially within electrical engineering and computer science. And we have a boot camp for girls, which we have named after the first engineer in Sweden, female engineer, Vera Sandberg. Chalmers has also just recently made a decision on a 20-year strategy. And this strategy tells us that 2041 should be a European leading university. We should use our freedom as a foundation to increase the financing of our research. And just this week in the education management group, we started the strategy work for 2041. To how should Chalmers educations look in 20 years. And then I give the word to Jimmy Enberg, who is the head of the program.
Thank you, Jörgen. And thank you for inviting me. As I said before, my name is Jimmy Enberg. I'm head of the program in electrical engineering, the 5-year program, the civil engineer program. So when I was assigned this task, I need to find some kind of theme for it, because when I thought about, should I talk about how it looks today? And I said, it will be a quite long presentation and very, very static. So I tried to get another perspective, the 120-year perspective. So what happened? What is the difference from 1902 and 2022, where we are today? So what we see here is actually Campus Johanneberg at 2 different ages. So go directly to the interesting thing. What were they actually studying? I went down to the central archive and tried to find this. What were they actually studying? And you can see that, sorry, it's in partly Swedish because I couldn't really find any translation for this. But first I had a lower part where they spent 3 years studying mathematics, mechanics, physics, circuit theory, basic about electric motors and measurements. And then they had a 3-year continuation where they were looking into telegraphs, telephones, new thing coming up here. Analog filters, telegraph equation. Some you might have solved it or tried, which may be the most common thing. Talking about short power lines, motors, transformers, 2-port equations, batteries. Lighting was a big thing then, which we don't have. And they were also looking forward into the future, ultra high frequency technology with coaxial cables and waveguides. We are still looking forward, but maybe and also in this area, but I think that ultra high is a different ultra high nowadays. And once you see what we have today, I mean, the basic is the same: mathematics, mechanics, physics, circuit theory, motors and measurements, of course, but we also added things. Computer engineering, software engineering, but it's also a lot of soft skills or generic skills. Because what we're seeing as the task of an engineer today is so much more than just solving the equations. We need to understand how it's used. And that is just the first 3 years. We're putting a lot of pressure already there. But then we have the master programs. Jürgen was also listing the 5 that we have got, and these are the ones that are associated with electrical engineering. So they are the ones that we mainly think of as electrical engineering, but they can select another 8 to make this happen. So this is how the program looks today. And what you see here is yellow is a lot of electrical engineering, but we also have a lot of math, red, physics, blue, and some opportunities to make choices. We also had our first teacher, Fredrik Lamm, as we talked about, and he was remembered as an inspiring teacher who really cared about his students. And I think we see him here in action doing the electrical machines. And lab has always been an important part. And this is how it looks today. Here you see a comparison. And here we see a current picture of what is happening in our lab today. You see a lot of differences, but you also see a lot of similarities. And lab has been an interest for many students. During the time, a lot of proposals has come in from the students. We want more labs, we want more. And here's one of those notes that was written by a student called Åke. I don't know who, but that's happening. And then also, I mean, you said before, I heard some people saying, when I started in 1987, we were 240 students. Yes, you probably were. I don't deny that in any way. And today we only accept 60. In some way, yes. As you see, we have 66 students admitted this year in electrical engineering 5-year program. But we also had 56 in the 3-year program. And then we have all the master programs, the 5 there. So you see there are many more. Those were admitted for the 4th year. But should also remember, and there were only a handful in 1902. But as I said before, that electrical engineering has been divided into different topics. Computer science, for example, with their master programs, and the Bachelor of Engineering. Information technology, also based there. Automotive engineering and mechatronics, also of course based a lot on what we need. And our latest edition, medical engineering. So when you try to sum up here, it's actually more than 240. And finally, I would like to make a very short thing. A short thing I realized that something hasn't been much better. Or it wasn't better before, in that sense. So I found some notes where people have been cheating. I don't know when, because for some strange reason, they didn't write the name and date on the cheating papers to the left. But on the right, I know that this is definitely from 2022, because it was handed in a few weeks ago together with the exam. So, as I see it, electrical engineering has happened a lot. A lot of things are happening, but there is also great similarities. And I think that will probably continue for another 120 years. And even though we have been working for 120 years together, we probably need to continue at least another 120 years. Thank you.
Thank you, Jimmy. Thank you, Jürgen, for this energetic introduction. And we are a little bit late, but I would like to introduce Ola Karlsson, Professor Ola Karlsson, who's really been a key of the whole program, but he will be the panel moderator. Please enter the stage and initiate your panel. It's about energy, power, and energy supply. Welcome. Give a big hand to Ola.
I think you can come up immediately, please. Yeah, please have a seat.
Okay.
Först Nina Böckling. I also think your second name is today. Me and Nina were colleagues roughly 10 years back now, something like that. someone should put it on. Yes?
Not yet.
No. I start with this one.
Yes, please.
This working? Okay. It's better? Yeah. Okay. So Lina, these days you are a professor at KTH, working with power system and develop things around them. So welcome. You will present a little bit more later on. Massimo, we have been colleagues in the electric power engineering division for many years. You had advanced and now professor in power systems. So very nice to have you here. Myself, Ola Karlsson, has been working in electric power engineering for also many years, and working mainly with wind turbines and power systems and a little bit of electric cars also. So this is a great opportunity to have this subject today. There should be some slides that I give the people there, how to do that, to get them up on board. There we go. Okay.
And now you want to start?
Yes.
Just point and press.
Okay. Yeah. Okay. Push that. Okay. Nice. Thank you. Okay. I start very broad. This is an outlook from the Norske Veritas, the DNV. They make an energy outlook every year. Yeah. Okay. Still working? Okay. Yeah.
Ola.
I don't catch. Point in that direction.
Yeah, because it's the Bluetooth receiver. There you go. Point there. There you go. It's you guys.
This is too much for me. I do as I used to do. Sorry. Yeah, what we see here is the energy use in electrical grid-connected electricity generation in Europe. 30 years back, it was coal, oil, gas, nuclear, and some hydro. And that we realized that this can't continue. We have to change. And I was employed in 1980 by the old professor Svante von Zweigbergk, and I said I should work with wind power and power electronics. So he was really a guy that could see the future. So that was impressive of him to realize this. So what we see today is that the sun and wind, onshore and offshore, has come a little bit right now. But what is the Norske Veritas thinks? That this will be the solution for the future. In the future power system, there will be floating offshore wind, there will be offshore wind standing on the bottom, will be wind on land, a lot of solar power, some storage, hydro will be roughly the same, bioenergy roughly the same, nuclear roughly the same, coal and gas has disappeared. And this is what we need to do to save the world. So I hope we can all work together to get this way, and how to get it we will discuss later on today. Just take a look at wind in Sweden. What we can see here, the line here is the energy per year of wind. We are here today. So roughly 35 terawatt hour of wind in Sweden is produced out of 160, or 165 to be clear. So we are quite good there. And in coming 3 years, it will be over 50 terawatt hours. And that was in the order books of the companies. That's not plans. There are money behind every terawatt hour there. So that's great to see. And if we compare the power of wind, a couple of years back it was more power in the wind than in the nuclear power plants. And this year it will be the same amount of power in wind as in hydropower. And the energy will be the same as hydropower in quite soon, yes, also here. And it will be more than nuclear power quite soon also. So this is what we see the forthcoming of wind. And if we look to Svenska kraftnät, they give out also some kind of energy outlook or development plan, they call it. There we see, oops. There we see in 2045 there are different scenarios. But one scenario point on double up of energy consumption in Sweden. So we've seen the biggest change in power used in Sweden for the last 40 years. It has been constant, more or less, for 40 years. And now it will be double in the coming 20 years. Do we fix this or not? Is this possible or not? Is this realistic or not? That's the question Lina and Massimo will answer later on. Yeah, I think I end there and give the word to Lina. Or was it Massimo? We'll see who will come up here. Yeah, Lina.
I will try. Yeah, it works fine. Thank you so much, Ola. I'm very happy to be here today. Ola and Massimo has been my colleagues for a few years back in time, so I'm very happy to be back today. And I will give an introduction here, and then I hope we will have time for discussion. I have two roles today. I'm a professor in power grid technology at KTH, and I'm also director of the energy platform, which is similar as we have here in Chalmers on the energy advance. So it's really stimulating collaboration within energy. If you want to contact me afterwards, you have my email and I think I put my Twitter as well. Yes, thank you. Thanks, first of all, for inviting me. I have very good memories from here, and I included here two pictures that will symbolize, as I see it, one of the really main activities at university, both related to science and education, and it is to arrange meetings like this and conferences. And I have two very, very good memories of that. The first one is at my home university at KTH, where I arranged a conference in the probabilistic methods for power system. But the other one is here at Chalmers with many of you colleagues, where we had the first ISGT conference in 2010. Yes, so it's more than 10 years ago when we had a big international conference on the smart grid here in Gothenburg. I will obviously not bore you with my background, but I said that I've been here for 5 years working as a professor in my past, but now I'm back almost 10 years to KTH, where I have my education. And if I only had one slide, this is what I would say. So I tried to start with a summary. Like a month ago, I was interviewed by our main magazine in Sweden, and it's quite unusual that we as engineering they spend interest on us. And also, if you work in power grid, it's not maybe so common that people are interested in that. But for the last years or year, it has been a great interest in our field, in our topic. And normally, the big interest from society comes when we have problems. So we have a bit of challenges in the grid. And I have tried, specifically during this year, to be very open when I get questions and try to help in describing things. And it has also been a challenging due to the election, that it has been a little bit of not every platform has been so independent in their information channels. So I have tried to contribute, and here is the kind of the main message that I try to say. So we are we need to stay in tune for our long-term goals. That would be the sustainability development goals. But we also need to work now on independent energy supply in Europe. That is very crucial, and we understand that from the war ongoing. But if you look in Sweden, we need to have some long-term plan, and we have to do it quite properly. We can see that now we are in a little bit of troubles because we have not managed to work so good in long-term planning. So this is something we need to improve and work on. And then there are a couple of things, a couple of technical things. We need new production, and we need more capacity. But maybe one of the most important things that I think all of us can contribute with is that we need acceptance for the society. Because in reality, we can't do anything if people don't want it. So me and Ola, for example, we like wind. So then we need to say, well, it's nice to have wind. and for most of us, we need to accept things. Otherwise, nothing will happen. So I think that's very important and things we all can bring with us. So I want to mention one more thing. Related to energy, I think it's so good that we are communicating and collaborate. And when I found this picture, and maybe you don't see it here, but this is one of the activities we did related to this when a professor from Chalmers is here. It's Philip Jonsson. And we were inviting to have like an independent panel discussion related to nuclear and wind that we had in end of last year. And I think from a university point of view, this is very important that we try to help society of being independent. And we also published a book this year related to this, to communicate with society. So what I want to underline today is this background, the motivation that I mentioned, but also reflections on the power grid. So that is my topic. So what I want to communicate is about the specifically vision we have. We call it the Green Grid vision, which is a vision how we can solve the challenges with a lot of possibilities in future. I included just one example, and then I'm making a reference to, as I see, a very good reference, that is the report published by the transmission system operators in Europe that are making very good prognostics for future. And obviously we will not have time to go through it, but I'm making a reference for it for your further reading. When we talk about the sustainable development, it is important, I think, to reflect. Ola was showing some of the changes in the portfolio of electricity. And what we have seen is that we have a huge increase in wind power all over the world, and it's coming now in solar power. So from the grid perspective, we have worked with for quite a long time on how we can integrate this in a nice way. Other things we have worked with is, in general, to use the benefits of the digitalization, and also to work on local generation. So this is something that's quite new, to work on the local generation, and basically to optimize the energy system. So we don't only speak now about electrification, but also using other sources, like heat, for example, and also to relate to different sources of storage, for example, batteries. But one thing that changed quite rapidly the last year is that we are again talking about nuclear. So this is something that's happening in Europe, and it's happening also in Sweden. So what we probably see is that we will have a little bit different perspective, and some of the forecasts that has been made will probably see different. So this is something that's on the table. It is very important, however, to realize that we are connected. The power grid is interconnected. We are part of the European power grid. And this is something that's very important to realize, because today we have a little bit of tendency to be very national, and some organization want to cut the lines, etc. But from the technical side, no, because we have a very nice optimized system where the part is that we can transfer electricity to different neighbors. So this is a very nice system we have. And March this year, something happened that was very, very unique. And as an effect of the war in Ukraine, within the European Union, we were pushing through a bit faster the plan to connect Ukraine and Moldavian to our electrical grid. So in Europe now, we have the world's largest connected power system, where Ukraine and Moldavian is part of it. And this connection happened on this specific day in March. So this is something quite interesting, where we technically are actually supporting for the stability in that country. In Europe now, we are collaborating to push to manage the energy supply. Because it is a challenge for us now when we are doing a blockade from major import. So this is something that making these issues very, very important. And we created this plan in the beginning of the year. And as you probably know, now we are preparing a lot of changes actually also in our law system, because we will soon have a law on us to reduce our usage of electricity and in general on energy. After the COVID challenges in the world, European Union, I think, had a very positive way of trying to accelerate the energy transition. And one solution for that was the green package, the Green Deal. And for us working at university, this was very nice, because this is our new research funding, quite high TRL level, but a lot of investment, for example, in offshore wind, and things we are trying to invest in the industry. And this was something very, very positive that we can see from the development. And we hope that this way of investing us out of crisis is a very good thing. So now we'll spend a few minutes on the vision that we have worked with together with industry to realize how will we shift the power grid in order to meet these challenges. And here we see that the power grid, we have the three different areas. One is an effect of the digitalization. And this is sometimes what we, the starting of the smart grid, that we have a lot of data that we can use to do things smarter. We can estimate, predict things, and we can also have customers that have information, so they can also move their consumption. They can do activities, and we can predict and make nice forecast. The other area is more related to the technical thing, and this is where we can create a new flexibility in the grid. For example, using storage, batteries, we have the EVs, we have the PVs, and it has been a huge development the last 10 years in this area. A lot of it is a result of new also power electronics. The third topic is related to what we say the circular economy. And this is something that is a trend that probably all of us will be related to in all kind of areas. But if we look at our specific area here, it's very much related to second lifetime, for example, for batteries. It can also be related to all kind of material questions, how we can use good materials, sustainable materials, etc. So these are a kind of a package of topics that we believe where we can find a lot of solutions to manage this change and shift in the portfolio. I included only one example to say that we are actually also working on this. What is quite unique here is that I see that we are doing research at the same time as we are publishing, the same time we are speaking about it, and the same time it's actually implemented. And that's very, very unique. And the interesting reflection here is that things are getting so fast, and it's new. It's really a new technology that we put in the business because it's a new market. Svenska kraftnät now has a market where you can work with solar and wind, and you can create a value for the small customers. So this is an activity I wanted to show you. And I want to close with just giving a reference, because I know that some places in the society, people wonder, are we still working on the long-term plan? And I say, yes, we are. And here's a very good reference. So I will not go in detail in this, because we should use our time for discussion. So I want to summarize here, just to reflect on, it's important we have our long-term goals, and also that it's a lot of new possibilities that we can create, and also that we need the acceptance from the society. So thank you so much.
Okay, thank you, Lina. So good afternoon, everyone. And yeah, I just realized that I started at Chalmers 20 years ago. So basically for the 100th anniversary. And it's nice to be here now instead for the 120th anniversary. And what I will briefly discuss about is the future sustainable electric power system. And to start with, we know that the electric power system, as we have all studied, looks a little bit like this. So we have our main generation parts that are located on top of our system. And then through transmission, we bring energy or electrical energy to our loads, either from an industrial point of view and at the household. And from time to time, we can see some wind turbines and solar panels, etc. The question is, how should the future power system look like in order to be fully sustainable? What are the key factors that will enable such a system? And of course, we don't have one unique answer to this, but we have to see how the system will evolve in the future. But what we can see is what are the initiatives that many of the countries around the world are taking towards a zero carbon emission system. And what is interesting to observe is that the whole European Union is moving towards this goal for 100% power production from sustainable energy sources. And Sweden is one step ahead with that, with a very ambitious target of having a fully renewable-based system already by 2040. And if you look at the scheme here, this is the Swedish electric power production in 2020. And you can see that a little bit following what Ulla has shown, we have a big portion of hydro, that of course is our base source of electrical energy. We have nuclear, a little bit of heat and power and thermal, but wind, for example, here is gaining more and more space in our base power production. So how should the power system look like in the future? As I said, we don't have an answer, but one possible scenario is something like that, where we see that we'll have massive integration of wind, both from offshore and onshore. We will have, as we see already now, a lot of electrical vehicles connected to the grid that will participate also in the balancing of the electric power grid. Massive integration of power electronics at different levels, and more prosumers, so loads that will be able to interact with the grid in order to balance it. What we know are the characteristics that the grid should have. And beside, of course, the integration of renewables, following up also what Lina mentioned, then we need grids that are more and more flexible. We need grids that allow an efficient use of energy to increase the capacity and the availability of the resiliency of the grid. We just came out from COVID, and we have seen how important it was to have a stable electric power grid in order to communicate. And we have to provide infrastructure for electromobility and electrification process of industries. And we will have an extensive use of information communication, both to increase the effectiveness of the grid, but also its security. So what is important for sure that we'll have to take care of in the future is that we cannot work anymore just with one aspect of the future electric power grid, but we need to work with the entire value chain, the flexibility chain, from generation down to the end use of energy, because this has to be seen now as a system, not only as a component. And this connects to a recent activity that we started here at Chalmers, which is a newly sponsored center, which we call the Swedish Electricity Storage and Balancing Center, where we, together with other 4 universities and 25 industrial partners, are trying to connect a number of expertise from different viewpoints, different areas, all together towards the same goal of the future electric power grid. And there we are trying to build a platform where we can, of course, perform research, but also be able to understand what are the challenges, what are the opportunities, and what are the limits of the different technologies, and where instead we still have a white paper where we would like to perform more research and develop new technologies. I think I will stop here to leave more time for the discussion. So thank you.
Okay. Thank you, Massimo and Lina, for nice presentations. And now it comes to some discussion between us and the audience. So if the audience have questions, so raise your hand or some way, let me know. First of all, I will bring up something that you didn't talk about. We have seen this outlook that there will be a lot of more energy use in Sweden in the coming years. Do we believe in these numbers that the industry set up today? That do we really need a double energy within 20 years? If we look back, the number of people has increased in Sweden. The industry has changed quite a lot. Some electric vehicles come, but we use the same amount of power. Why should it change so much? Should industry talk about making steel with and so on and so on? And yeah, do we believe on the numbers? The first question. And if we don't manage to fix nice power to the companies, what will happen then? If you start, Lina.
Yes, so thank you so much for this question. So I think a little bit like this. Maybe a year ago or something like that back, there were huge interest specifically in the northern of Sweden, with a big initiative from the industry coming, where we could see that it was quite an expected huge need for electricity. And one of the drivers there was really to accelerate the energy transition and to reduce emissions from the industry processes. And I try to have the positive aspect of this and think that it would be really great for the world and for Sweden and Europe if they would manage that, because a lot of those ideas are very innovative. They're very new if you look at hybrids and these things. So in my mind, I hope that will continue. And I saw in LinkedIn in the morning, for example, that they are now planning an offshore wind farm outside Oskarshamn. So in my mindset, I try to think the more the better. So if we consider that we will still build wind, a lot of wind, then it will be offshore. And if we will manage with this small modular reactors, and we say that we will put them where we already have nuclear, so Oskarshamn, for example. If we will do that, I think we will manage to feed these new initiatives. And I think that would be a good solution. But we have to sort out some of the problems we have within the country with the capacity increase. But now this problem is very known. So I think the push is much higher now on the responsible organizations to solve that. So I hope that we will continue with this long, very ambitious, because it is very ambitious with our industry changing, but it is amazing if we can do it. And if we can do it, it will be export industry of knowledge, and it will be benefit for the whole world. So I really hope, but that is, I know, maybe a little bit risky and costly, but if we will manage, it will be very good. So that's what I hope for. Yeah.
Yeah, we can hope for the future. We don't know the future, that's one for sure. Mm-hmm. Okay, Massimo, have you any ideas around this big task?
Yes. I think that it is true that the amount of energy needs, electrical energy needs, will increase a lot in the future. But exactly as you said, Ulla, I mean, it will not increase just because the load is increasing. Because at the same time, the efficiency of the loads is changing a lot. It's enough to look at the lamps that you have at home, how much they were consuming before, how much they're consuming now. And there is also another aspect, and that is that with the new technology, then the efficiency of the transportation of electrical energy is increasing. And at the same time, we tend more to have local energy production more than what it was before. Wind is a typical example. So that it will be double, then I have some doubts. That it will increase, then I'm quite sure about.
Okay, nice. Yeah, what something from the Well, yeah. Should we? You have some microphone there, so bring it in.
Thank you. My name is Klaus Berlin. You can hear me? Yeah. And I started here in 1969. I have a little question here. How can research work more close to political decisions and vice versa in a positive way? How do you see that from your point of view, please?
I think Lina have some good example how to get close to the Riksdagen at least. Please go ahead.
Yes, thank you. So thank you so much for this question on how we think research can reach closer to politicians. And then I want to mention, as Ulla knows, that we have a very nice organization in Sweden, in the parliament, which is in Swedish called Riksdagsledamöter and forskare, which is a volunteer organization where there are two part of members. One are researchers and one are politicians. And I can say, happy for you here, that one of the new members from the parliament people is actually Anders Ådahl. So that's very nice. That comes from here. And I'm currently the vice chair representing the researchers. So this is a fantastic organization where we actually arrange seminars in the parliament. And those seminars, we try to focus on topics where we think it's needed with knowledge. So the whole idea is that we believe in knowledge in the society. So all parties will have same knowledge, and the knowledge should be independent and based on fact. So we are regularly arranging seminars. We will soon have one on electrical aircraft, for example, in the parliament. And I think generally what we need to do is to communicate. We need to have dialogues, and we need to continue because it takes time, and it's about the trust, I think. And currently, I just had some dialogues earlier today, and I'm a little bit disappointed at the politicians at the moment. I have to say, but we need to have the hope. Okay, so we need to continue and continue and continue. But for the last years, they have not done a good job. So in some discussions we do now, I have been in meetings where we actually don't have politicians. It's only academics and industry people. Because in some discussions we are tired about politicians and we don't think they contribute at all. So I think, but we have to continue. That I think it's my main message. But on the other hand, we have to make also be sharp and say that if they cannot solve it, we will just continue, because this question is too important to let political elections take it. So we need to work more long term. But of course, it's our responsibility to make a good election. But to continue the dialogues, I think is the most thing. Just continue on fact and on competence.
Just to add on what Lina said, another important task is to also have a very good communication with our industrial partners and all our partners, because they are also the ones that can influence the decision, but also make aware what are the challenges and the opportunities that you have in the future. So that is why we tend to collaborate a lot close to our partners, not only to get the money to run our projects, but also to be able to tell our results, to listen to what are the challenges that they see, and to educate those engineers that one day will go to work in the industry and implement the different solutions. And because they are the ones that have the channels also in order to make aware of, sorry, I will look at you this way, to what are the opportunities, but also what we have to fix.
Okay, that's good advice. But I have another example of what we are doing today. We have a collaboration group between the Västra Götalandsregionen, some wind power companies, and Chalmers and RISE right now. And the working group in that project, they go to the different kommunala politiker and educate them. So if you have called me or Sarah, Sarah will come out and talk for 1 or 2 hours and educate, if I may say so, the political people wherever. Most in the Västra Götalandsregionen, but we are not so picky. So we can come and give a 2-hour lecture if you ask us for free. Or Västra Götalandsregionen is paying for it. Okay, there was some more hands was raised.
There is a guy there.
Yes.
I don't see. Please go ahead.
I really like your style, Lina, I just have to say before I start. My name is Christian. I'm an alum from 2014 from Chalmers. I studied electrical power engineering. I have 2 questions, actually. So one is that now that we have established that we need a lot of more energy in the future, and I know that there is an issue with permits for building new power plants. Most often, I guess, it's talked about for nuclear power, but also for wind power and other power plants as well. How short do you realistically think that we can make this process? That's one question. The other question that I have is...
Question by question.
Okay, fair enough.
Did you catch it clearly?
I think it's how do we catch up with the long permission times and the need for acceleration of power production, is that correct?
Exactly, and how short can those processes actually realistically be? Because for nuclear, I hear 10 years. For example, I don't know exactly how many years it is for wind power, but I think across the board, those processes need to speed up.
Okay, maybe I can start and then the other can complement. Of course, it takes time to build up something. It takes about 10 years to get the permission to build a power line at the transmission level. At the same time, if you have the need is the one that accelerates the process. I mean, you don't have to consider that it's only a way to move more power, more energy, to move it with the new power line or with the new generation unit. But it's also how you move the power flow and how you control it and how you provide flexibility to the grid so that you can distribute the loads in order to be able to guarantee a supply over the entire duration of the day, of the season, and of the year. That is also where, for example, the use of energy storage plays a role, where you don't have one type of energy storage that will solve everything. Everyone, when we talk about energy storage, talks about batteries. And that is because that is what we're used to when we are at home, right? Or when we have our mobile phone, etc. But batteries are good for a couple of hours. Then you have to go to supercapacitors, you have to go to hydrogen, you have to go to hydro, pumped hydro, etc., etc. So it is the combination of different aspects that in the future will play a role in order to be able to supply the customers. It's not only generation, transmission, consumption. If you look at what Göteborg Energy is doing, since we are in Göteborg, consider that they are investing, I think that in 2021 only, they invested 300 million crowns in their grid. And that is only to provide flexibility to the grid.
Okay, thank you. So maybe I can add on a little bit. If you want some dates and numbers, when we discuss the specific question, what people tell me is, if you look at SMR, small nuclears, they say 2030, that should be able to produce. And in that context, it has obviously have to be at location where they accept it and can do it. So I guess it should be Ringhals or Oskarshamn. But 2030 is what they say. And related to wind, there are several projects where they're ready to start to build directly, because that technology is here, and the investment is here, and the money is here. So that it's more a question of starting to build. And they were, end of last year, they were declining a couple of projects in the south part of Sweden, where they are ready to build. So what we are hoping now is that some of these decisions could be revised. So then they could start build them immediately, but obviously it takes time, whatever we do. So. But to build wind and will be fast. It's just start doing it. But of course, to get it operation take a few years. And for small nuclear reactors, they say 2030. But I totally agree with Massimo that we have to look at the other parts as well, because it's not only new production. But I think in your question, you talked about energy. So in energy, we can say that we can have other things than electricity. And what I'm trying to communicate is that we should try to be open to all kinds of technologies. And some of the technologies are actually that we should not need electricity, that we should use heat, for example, waste heat. So I think it's important to look at the alternatives. But around 2030, I would say, is realistic for a lot of new generation.
Yeah, thank you. You're absolutely correct. But I would fully agree with you. I think if we ask what can the political people do on local level, regional level, or Sweden level, or European level, if they speed up the permission, that will be the most efficient way to solve the problem, absolutely. So by doing the permission much faster, it will be much better, absolutely. I can agree there. But how, I can't answer. Okay, you have a second question, or should we go further on?
I think you have a second question.
Second question then. My second...
Linda is over there, okay.
But you had the second question first.
Is it okay?
Yes, please.
Yeah. Okay, so my second question is in regards to VPP, virtual power plants. For example, Tesla are working a lot with VPPs, which would help regulate the grid frequency. And it could also help shave off peak loads and so on, which is obviously extremely beneficial for the electric grid. My question would be, what do you think, personally, that the installed capacity of EVs would have to be to have a meaningful impact here? How many kilowatt hours would we actually need? It's a bit of an abstract question, I know, but if you can...
No, it's not that abstract. Yeah,
no, I mean, we are excited to answer your question, because, I mean, this is a topic we have worked with for so many years. And then first thing happened when I came here was that Ola gave me a project and said, you run this. And I said, okay. And that was related to EVs. So we have worked many, many years on modeling the impact, the benefit of having a large volume of EVs. And how that can be aggregated to impact on the market. And for many years, when we started to work on this area, I remember that a lot of people didn't really take it seriously, not at the national grid at least. But now we can see this is reality, this is happening. I just answered a question from my students in the morning. We are doing some modeling, and they say, is this a realistic assumption to assume that you can connect all EVs to the grid? And said, yes. Yes, definitely. That's what we will do. So definitely, I don't give you a number, but it should not be too difficult to. It depends on. But yes, we will have EVs, and the EVs will be part of this flexibility to feed into the grid, and it's happening. It's happening quite soon. We're starting on it. Yep.
Yeah, and you. Sorry, Ulla, please.
Okay, maybe I can try with some numbers. If we have all personal vehicles used electricity, they will use roughly 12 terawatt hours. Today we use 145%. produce 165, export 20. So, I mean, and we talk about an industry development of 100 or 200 terawatt hours. So the EV extra consumption of electricity is small. If it rains heavily in Norway and northern part of Sweden, that's 5 terawatt hour in that rain. So EV is not it's not a problem with energy. Maybe local power consumption can be a problem. If everyone would like to charge very quick, then it can be a problem. But I guess EV will be bringing up in the next session also.
And then you were talking about Tesla. And I mean, it's true that Tesla claim that they can access their cars and demand the discharge toward the grid within 1 second, which is quite impressive. But when it comes to frequency control, I mean, my students know that I always say the best answer is it depends. It depends what you want to do with your EV, what kind of frequency support you want to provide, because you know that there are different types of frequency support. If you want to provide primary or secondary frequency support, then, I don't know, maybe. But if you talk about fast frequency response, reserve, for example, so when you need the system is in danger, and then you must be able to act quickly so that you help the system abruptly. There you have a huge potential when it comes to EV. And there you don't need a lot of energy to be able to support the system. You need maybe some power, but not much energy. So it's for a short time.
Thank you.
And for charging also, the EV today, that runs roughly 330 kilometers per day. The battery can withstand 300 at least. So you need to charge once a week. And there's always sun once a week, or there are wind enough for charging once a week also. The wind is coming every 3 days. So no problem is my conclusion.
All
okay,
right.
there was something more of it.
2 questions at least, and those of you who are on YouTube, start using the chat and we will capture your questions as well.
All right, I have a question here. This is Joachim, GVL. When will the solar power speed up like the wind power is doing now? And how long will it take before sun power is a main part of the Swedish energy system?
If I may answer, it will never be main part, if I may say like that. That's my conclusion at least. It will be some part, and it will be a high power during summer, absolutely. But the hours that the wind the sun is acting is roughly 1,000 hours a year, fully load from sun. So there's not so much energy in the sun, so it can be a big part of the power system. It can contribute very much in the summer, but not in the winter period. Sure, if we save water from the sun in the summer, we can use the water in the winter, but that's also limited in some way. So not 50%, not 20, but maybe 10 is my guess. What do you say, Lina, about that?
I would say that I agree totally in short term, but if you look very long term, we had a seminar at my university yesterday when we talked about fusion, for example. So, I mean, if you look very long term and you look at material science, it's a lot of very interesting things to use solar. But that would be a different technology. But in very, very long term, at least in my mind, I think a lot of when you integrate in material, so you can attract and use solar. But that will be a different type of electricity and energy usage we talk about now. But in very long term, I mean, I personally believe that we very long term will have fusion or other energy solutions, and then the solar will be used in different ways and integrated in materials, etc. So, but that will be very long term. The solar we are mentioning here will never be larger than the wind. I don't think so.
Okay, thank you. Are there some questions from... There is one, okay.
Linda.
Oh, I just talk and it's on. Thank you. Well, I have a comment concerning the permit process, the long permit process. Was a question a few minutes ago. And I've been part of the Swedish Electrification Commission for 2 years now, and a lot of work has been going into it. How can we actually short those permits, permission times? So I know there's been a lot of effort put into that, and how one can actually parallelisera the processes to shorten the time. So it's actually been identified to be very important work in order to make electrification happen. So just wanted to mention that. Thank you.
Okay, thank you. Is there?
Yeah, well, thank you so much. So far, I have one question. Being really into innovation issues, so if you were to say 2 or 3 areas where you think Sweden could play a role when it comes to innovation around energy supply, energy power in the years to come, and not just for Sweden, but I think globally, where we can really, we are a bit strong, we are ahead of things, we know more. What 2, 3 areas would you recommend? And you can do your own recommendations. You don't have to be...
In my case, I have to say that I am biased, as Anders knows, since...
I will follow up that question.
Okay. Well, I think that, of course, when it comes to power electronics, there is where Sweden has always been a world leader. With ASEA, with ABB, now Hitachi Energy. We have the island of Gotland that has been probably the most cited island in the world when it comes to scientific publications. And that is something that is continuing all the time. So I would say that power electronics is a very important area that we have in Sweden. And there you see that in the past it was mainly for transmission systems, and now it is for all the power and voltage levels that we have in the grid. So that, I think, is a good example.
I think this is a very exciting question, and I think it's really important to think how we can have innovative solutions. And earlier this week, I was actually attending a seminar that we were sending at the COP27 live activity, where we were handing out a prize to start-up companies that are working on innovative solutions for solving energy climate change. And I think that was very inspiring, because what we're trying to do is really to stimulate to new ideas. And I think the technical universities really have a good mission here to take up the ideas and promote the students to come up. Because I think, I mean, one part would be the technology thing, but another is really to understand the behavior of the customer. Because we were actually laughing at that point, because when we're starting to work on what we call smart grid, we had a problem where we said the customers are not active. And we were discussing this it was very challenging because we didn't get them active, but now they are active. But it's very interesting that they are active, but then they don't act as we think they do. So I think it's a lot of innovative solutions in how we can reach the behavior of people, and how the behavior of people could be, because it's not only based on cost. That's what we realize. It's based on heart. It's based on the feeling of change. So I think here we have a good thing in Sweden. I think we have a good culture of collaborating, of listening between different sectors and actors, etc. And here I think we can really stimulate for new ideas. So that's something I think we are strong in. And we were giving prizes to 2 topics related to industrial processes, actually, to use things that are very innovative. Thank you.
From my perspective, it's interesting also to follow up with a question about how to collaborate with other type of researchers. You haven't mentioned the introduction of AI and optimization tools for larger and more difficult optimization problems. Could you elaborate about that?
May I start then? Yeah, we just have a PhD graduated 1 month ago, that he trained the power system behavior, so he could, I would say, when there is a problem, if a power line go down, there's a risk for instability in the voltage, and that you don't see after maybe 1 minute in normal case. Then the voltage go down and then everything break down. But he trained his machine, his computer, so if after 1 or 2 seconds he was able to see now we will have a problem or not have a problem. So you could act long time before the problem occur due to machine learning. So that was really fantastic to see that the mathematics could see this problem, for example. So yes, we're working quite a lot together with them. But you have maybe more example, Lina.
Yeah, maybe I can, very exciting. Maybe I can just add that maybe if you remember in my figure of the green, the first topic was related to digitalization. And there we are focusing on the machine learning models. And a lot of the, personally we do predictive models for maintenance optimization. And when we do those calculations, we are connecting to our big computer database at the KTH. So we're using the parallel computers to do the calculations. So definitely in the modeling, we are using AI and a lot of data resources. So that's very important.
Yes, and if I can still add once again, if you remember, Lina, the first PhD student you have when you come here 12 years back or something like that. And here was usage to work with maintenance and artificial intelligence. But the old professor didn't like that. But we continue. And now this guy is development manager in a company that work with this in a wind turbine, with thousands of wind turbines acting on that. So that's really a success of that story. Very nice.
That's great.
Maybe can I just add one small thing? I mean, I think that optimization and system information communication, call it in general, AI is a branch of that, connects very much to the comment that you had before when you were talking about power lines and how long does it take to build generation, transmission, etc. I mean, in the old days, then we were dimensioning our power system for the peaks of the power that we had, even if the peak was for a very short time over the day, of course. I mean, the optimization and the control and the communication is what will allow you instead to spread out things and to really optimally use the assets that you have. That is where, I think, in our grid, we'll have the main impact in the future.
Thank you. Well, we're done with our first panel. First of all, Thomas Koberger should have been here. He was ill this morning, so he says hello and he couldn't make it. So I think you guys did super well even without him. I hope he agrees. Thank you so much, Lina. Thank you, Massimo. Thank you, Ola.
Thank you so much.
We now are many here who need a short bio break and perhaps some other breaks. So we'll be back 2:45, and then we will sharp start the communication 5G, 6G panel. Okay, a little break. All right, hope you had a nice break. We are continuing with the panel on communication, 5G and 6G. And welcome Arne Svensson. You will introduce your panel and do it in your way. Go for it.
Thank you very much. I'm very honored to moderate this session on communication, 5G and 6G. We have 3 speakers, one from industry, one from authority, and one from academia. We have Cecilia Attervall from Ericsson. She's Global VP and Head of Marketing and Communications in the business area Networks at Ericsson. We have Bengt G. Mølleryd, Senior Analyst at the Swedish Post and Telecom Authority, PTS. And then we have Tommy Svensson, who's Professor in Communication Systems here at Chalmers. I will first start with one picture with a little bit of history. Maybe all are not updated on the history of mobile communications, as you see on the left in this picture. 1946 is, maybe it's a surprise to many, that this is actually the birth of mobile communications. The first trials were taken in USA. And this is normally considered the birth. Then it took more than 30 years, which is unusually long for technologies like this, before the first system actually was made commercially available. And that was a system in Japan by the operator NTT. The first 1G system in Sweden was the Nordic mobile telephony system, which was introduced in Stockholm and Oslo, I think. And this was in 1981, so 35 years after the birth date. This was basically because the technology was not available until then to implement these systems. And up on the right corner you have an early NMT mobile phone from Ericsson. It's a bit heavier than the ones we know of as of today. Then probably most of you have heard about GSM. That's a 2G system, and it was introduced first in Finland in 1991, and then quite soon in many other European countries. This was actually to begin with a European system, but it more or less became a worldwide system after a couple of years. GSM was in the beginning, it stands for Group Special Mobile, which was a group who standardized GSM, but then it was renamed to Global System of Mobile Communications. But in the beginning, many people said, God send mobiles, because there was a big lack of mobiles in the during the first years of the GSM introduction. Then you see the dates of 3G, 4G, and 5G. And Cecilia will say a few more words later about the differences between these systems. So I will leave the systems by that. On the right-hand side, I have a little bit of history of myself and the Communications Systems Group at Chalmers. I started as a PhD student in University of Lund in 1979, about the same time as the first 1G system was introduced. I worked on receivers for the system later to be used in GSM. And at that time we had a very, very nice group called the Mobile Radio Group in Sweden, where we had an informal cooperation between the different universities and Ericsson and Telia. It was led by the CTOs at Ericsson and Telia at that time, and very nice cooperation, and we did a lot of work that actually contributed to the GSM standard. Then I went to Ericsson for a couple of years and worked with a 2G system in Japan called PDC. And then in 1993 I came to Chalmers as a professor, started the Communication Systems Group with 2 PhD students the first year. This group is now about 40 people, so it's really increased a lot, been very, very successful. We started to do some basic research for 3G, and then we and the researchers have been involved in in EU projects and many other things for all the systems, 3G, 4G, 5G, and now 6G. And you see a phone for GSM and a 3G phone, and the more modern phones you probably have in your hand, so I didn't include them on the picture. So now to our first speaker, Cecilia Attervall from Ericsson. Please come up.
Thank you, Arne.
So, go ahead, please.
Thank you. Great to be here, back at Chalmers Mater. More than 20 years since I graduated, and I still wear the ring proudly. Do I have any fellow ring bearers here in the room? A couple of us, at least. Avancé. Sometimes it helps when life is tough. You look at your ring and you try and move on and make the world a little bit better. So, talking about mobile communication, I wanted to look ahead as well. So we are here today to maybe have a little bit of a retrospective, but I wanted also to share a bit of glimpse of the future. But before that, what has enabled us to see the mobile miracle that we have today? Well, a couple of foundational pieces are there. This is an industry, the telecommunications industry, that's thriving on standards. And Ericsson and Sweden has been crucial in developing this for global leadership. As we have this today, this is what enables us to pick up a phone in Sweden, go abroad and pick up a SIM card in the US, plug it in, travel to Australia, call a friend in South Africa, and it all works. You just sometimes have to have an adapter to charge the phone. But the system works, and it is because of the fact that it has been globally standardized. All of these generations have had sort of a foundational service that has then led to a lot of innovation around it, enabled a lot of different industries to thrive with it. So if you think back, maybe in my case, my first mobile phone, I actually got it here at Chalmers. It was my dean, Kent Lumsten, who said, I got this from the master, the headmaster, but I don't know what to do with it. And as you're organizing the freshman welcoming committee, 0K, you can have it, and maybe you can coordinate all of it for your section. Now, no one else had a phone, so I couldn't use it for coordination. But it was in 1994, and it was a phone that I could use for calling and texting. Then as we moved forward with the different generations and enabled mobile internet, not only did we have a technology that worked, but we also got an ecosystem around it with the phones to make it happen. And with 4G, we developed a system that, after having spoken about mobile TV for a long time, got video to be the main traffic source in the networks. So from 4G and onwards, 75% of the traffic in the networks is actually video. But all of the previous generations up to 4G were all about consumers and enabling new things for consumers. 5G was set out to enable a whole new paradigm and connecting everything. So if we had moved from connecting places to people, we're now about connecting everything. And that is another level of complexity. It creates even more need for co-creation and working across industries to make it happen. And then, as we move into 6G, we're looking at an even more exciting future. So I wanted to start by a vision of what 6G could mean, and then have us think a little bit about what it would take to enable that vision to happen. So, imagine a seamless reality. Imagine a reality where you could have a digital representation of everything that we see in the physical world. And you could have these two interwork together. So with the help of sensors in the physical world, you could then recreate in a digital mirrored world and program things in that digital world that you then, with the help of actuator, could make happen again in the physical world. So just translate it into something that means anything to us as human beings. Today we're interacting and using internet for audio. I mean, we see things, we hear things, right? But in the future we are looking to forward to a vision of Internet of Senses, where you have an opportunity to also get the tactile, the feeling into it, the taste and the smell. And of course, then you need a whole lot of other technology, but with the underlying connectivity enabling it all. We also believe that there will be a lot of interconnected intelligent machines to make this happen. So you need clusters of AI to think and act proactively without human involvement. And then of course you need to think about the security and privacy of making those happen. But with the help of all of this, it's also an opportunity to solve some of the biggest issues that we have in the world today, to enable a greener society, a sustainable society, because we need together to find ways to halve the CO2 emissions to 2030 and again halve them to 2040. So with that, we believe that as we evolve and think about 6G and all the and we will discuss a lot more with Tommy on what are the underlying technology fundamentals to make that happen. Having such a vision in place could enable us to co-create and work together in a whole other way. And if any one of you was thinking, what did she now say? She talked sensors and AI and what are all these things? Well, I actually also brought a little film, because some of you might like to see things rather than just listen to my words. So let's look at it together and see if you can recognize some of the things that I spoke about in this one. So anyone saw the couple holding hands and seeing that the man was actually a hologram, but still with that touch? Just one of the things you could pick up. I was also saying that this will take a whole lot of effort to succeed. And as a matter of fact, with Ericsson and the academia, Sweden has been a leading force in driving the innovation in mobile communications across all of the generations. Now we're at a point where it will take more from what we do today to make it happen. So with the leadership that we have in 5G, it is still so that we have some major issues that we need to solve together across the industry, across academia, with the political forces that we need today. One of the problems that we see is that we need to invest a lot more in education, in STEM areas, all the way from kindergarten and all across the educational system. Today, we already see that we will lack by 2030 30,000 engineers in Sweden. And Ericsson, being the single biggest employer of engineers in Sweden, we see this as a major problem. And I say Sweden a lot, but I'm talking about an international sense, because we have more than 100 nationalities employed with Ericsson in Sweden today. We need engineers. But we also need the cutting-edge research, and we need to increase and concentrate the cutting-edge research to a few leading universities, such as Chalmers, to make this happen. And then we also need that cross-industry collaboration. So with Dennis Helfridsson from ABB here, for example, we have created an initiative together with Ericsson, ABB, Saab, to what we call advanced digitalization. And we need to drive this forward and invest across industries to ensure that we move beyond those great consumer implementations and ideas into actually making a difference for industries today. So with that, I hope we can all join forces in keeping Sweden and all of us on the map and a leading innovation nation going into 6G. So with that, over to you, Anna.
Thank you. So for Ericsson, it's the acronym USE. Universities send engineers.
Yes, please.
Thank you very much.
Thank you.
So now to our third speaker, Bengt Mølleryd. He's from the PTS, the authority in charge of frequencies and other things in Sweden. Please.
Thank you very much. Thank you. And thank you very much for the invitation. It's an honor to be here today. 120 years of Electro. And it's also, I think, for myself personally, a tribute to my father. He was of the class of 1947 of Electro. Do we have anyone who has been from the 40s? From the 50s, maybe? Yeah, right. So it's an honor for me to say a few words on the mobile communication. And I say 3 pillars. It's 3 factors. So what I would like to say here is, it's perfect. Engineers, you are excellent. But what I want to say that it's not enough with you. We need something more. Technical development is one thing, and then something else should happen. And as was underscored by Cecilia here, market, people buying things. There is a demand. We want something, we want to pay, then things start happening. And if you look particularly about the mobile communication development, as Arne said, from the 1940s, 50s, there were monopolies, the NMT. It's what we call a liberalization. It goes from monopoly to competition market. And if you look historically, probably one of the most important decisions was to liberalize the market for terminals, because the biggest investment is the terminals. And the terminals was very expensive. And today, maybe the price is roughly the same in kronor, in SEK, as it was earlier on. But the big money is from terminals for the investment. This means that the consumer, the users, has to see the meaningful in this technology. And the other thing is that opening up the market is also providing spectrum, the airwaves, to have the right to use the electromagnetic space. So with that, we have competition, we have consumers, we have companies, we have the money, and then we have this perfect technology. All these things happen. Then we have a mobile development. So technology development and the demand development, all of these 3 things has to happen, and then things happening. And if you look particularly at the 5G, it's interesting, as Cecilia said, industry in new pine. But sorry, it has not yet happened. I'm looking at Korea, for example. What do they do with mobile 5G? They have mobile broadband. They watch e-games. They watch baseball. They use it as a media. And if I ask the companies in Korea, why don't you use 5G for industry? The modules are too expensive. We have some concern regarding security. So what I say, it will take some time. And it will happen, certainly, one way or the other. And I think we could go parallel to 3G. That it took a little bit time, it looked a little bit different than what expected. So my point is to see, depending upon how the demand side, how the company react, what they think of it, then things start happening. So these 3 things, the demand, the technology development, and the liberalization, or the competition spectrum, these things has to work together. So in that respect, it's techno-economics. So the engineers with economic capabilities are very attractive, I would say, for industry. And then, if you take this thinking, looking ahead to 6G, and who knows what 6G is? We heard one vision. I mean, there are other visions around the world. So what's ongoing now around the different research projects is to form the idea what 6G could be. But some building pieces is to integrate what we have on the ground, what we have in the air, and what is up in the space, to combine these things so we could have the multi-layer networks. So we could use satellites, flying base stations, different types of platforms, and now they should communicate. And then we have the airplanes, so they will also get the communication then. And then we put up some drones. And then you understand, it becomes complex. So what is happening here? And if you look at what's happening in the air aviation area, the digitalization of the sky is ongoing. But you need have a digitalized sky in order to have the more efficient management of the air and aviation. And then we can open up for urban air mobility, looking at these flying taxis and a very type of features that we will have in the urban environment, the cars flying. And then they will communicate. So, and then you guess what is happening now. We had problem with 5G, equipment supplier. We have security concern. What happened? Oh, sorry, yeah. You see? We are involved, PTS, at the 6G Connected Sky. So when we are talking about it with the technicians, you know, they get all engaged in the technology. You're hearing these taxis and satellites, they're combining. But there's cybersecurity. What do you do with that? And these are national questions, and you see the politicians. This becomes strategic. This becomes geopolitics. So these problems has to be addressed early on. So, I mean, in that respect, we have technology, but you have to understand what the technology will be used for. What are the conditions? What are the restrictions? And this is a huge undertaking. And if you look at spectrum, the airwaves, who is controlling that? It is decided on big world conferences every 4th year. It's like the Olympics of spectrum management. The next one is in Dubai next year, and then in 2027. But we have different, very strong economic forces. We have a satellite industry. We have an aviation industry. And all these, they want to protect. And at the same time, we have a mobile industry. They want more spectrum. And now we're going to combine what is in the air, what's in the space, and what is in the ground. And we can today use our mobile phones to connect with the satellite. So a lot of things will happen. What I would say, the users, as I said before, the demand, the regulation, and the technology, all these have to play together. So the users will determine the outcome, but it will also be determined by all the research and students that can form this development in order to shape a future. And also, I think it's very important for Sweden and for Europe to really regain, because it was no question that Sweden had and Nordic had the leadership in mobile communication development, and then with the GSM, Europe, okay, but what happened later? Anyone heard about Apple, Google? Yeah, every day we heard about them. And they are the smart on the software, and they are in that respect and the platform company. So what we know, we need research, we need ambitious students, research projects, and also more ambitious policymakers in order to have an idea of where to go. And if you compare Sweden to Finland, for example, Finland has a very strong, deliberate policy that 6G is important for our country. Anyone you heard about 6G from any politician anywhere? No, not yet. So there is a lot of work to be done. Thank you.
Thank you, Bengt. Thank you. And now to our third speaker, Tommy Svensson, here from Chalmers, please.
Thank you. So I would like to do a technology perspective on mobile communications evolution up to the research we do on 6G today. The reason why I joined the mobile communication industry was that I wanted the internet to my pocket. And that's what we did in 4G times. We open up for mobile communications with rich multimedia. In 5G, we put this on steroids by open up for high capacity and high data rate links, by open up for new spectrum, the millimeter wave bands. We also enabled Internet of Things in a more massive scale by wireless connectivity using so-called massive machine type communications that efficient small packets. We also open up for Internet of Skills, remote interaction by the help of low latency and reliability of wireless communications. Still some pieces to be done to get the full operation in real world, but it's coming. So what about 6G? Cecilia and Bengt have touched upon some aspects. So from technology perspective, we see a convergence of the digital, the human, and the physical world. But we, as also highlighted by Cecilia, 6G should play a role towards a sustainable society. We need to add the sustainability needs. So 6G itself needs to be sustainable. And by finding methodology, we should also be able to assess when 6G can help other sectors to be sustainable. From a technology perspective, as also touched by Cecilia in a nice way, Internet of Senses, we open up for new other information on the communication applications. And this we need to do, here we need scientific convergence, technology convergence of communications, of sensing, and of computing and storage, and powered by ML and AI techniques. Chalmers have been very active in enabling these mobile generations by the strong collaboration in Europe. We have the lead since 2G times. So all since Arne started 3G times in the frames, I've been active since 4G doing the projects and forward, and now we have a couple of projects, HIX-AX predominating now, and the next wave starts in January with the second version. And then we do system concept that feeds standardization. So some of the key technologies that powered 2G to 4G had the biggest purpose of spectral efficiency, getting up to data rate capacity. In the beginning, we started with frequency slicing, frequency bands to different users. With the digital techniques in 2G, we could do this in the time domain. In 3G, we had wider system bandwidth, so we started to spread the signal in time frequency domain to make them robust, the links. But then we start to realize in the end of 3D, okay, it's packets, so we should adapt. We should listen to the channel state and adapt. So that's what we did. Link adaptation, also follow many users and pick the good channels for each user all the time. And also fast retransmissions to repair and make the wireless medium more reliable. We also open up for granularity in frequency domain by having thousands of subcarriers. And that we didn't do by hardware oscillators. We did it with Fourier transform, for those that remember. It's a key math entity here, so please like it. We also open up for a lot of antennas. Because in the rich multipath environment, we can use the echoes to create palette streams, either to a given user or to separate users. In that way, we can boost the capacity by spatial reuse. If the channels are unreliable, we can do diversity by different ways of communicating of these spatial paths. Or we can use all the antennas to concentrate the beam and stretch the coverage to far off users. The 2D to 4D times operated in below 1 gigahertz up to a couple of gigahertz. Now in 5G, we open up for 30 gigahertz, so a factor of 10 higher millimeter wave bands. And in 6G, we look on the upper millimeter wave bands, 70, 80, up to 100 gigahertz, and also sub-terahertz, 100 to 300 gigahertz. And now we do well in the spectral efficiency in the given resource. We need to think about densification, how we can do that better. In the evolution of 4G, we started to densify the cells and reuse the spectrum. Then we got interference limiters. We started to coordinate the cells. In 5G, we started to deploy a lot of antennas, we call massive MIMO. So rich multipath, we can get channel hardening, channels getting stable, and we can have a lot of users in the same time frequency resource. With the millimeter wave, the propagation is worse. The scattering on the surfaces is worse. And the hardware is weaker, so we have less power to play with. We need to have very narrow beams, and then we need to match the beamforming at both transmitter and receiver side to find each other. In evolved 5G and towards 6G, we see further densification needs. We can't put fiber at all the base stations, access points. It's too costly. So we see the opportunity to reuse the wide system bandwidth at the upper bands, also for self-backhauling up to the core network behind these small base stations. We call it integrated access backhaul, IAB. Moving further densification, we see that we need to have unstructured networks where we adaptively identify the access points that can serve each user, or try to have the user in the middle. And there we also look into different kind, what should the access point be able to do? How much should we do in a central point? How much should we do out? And the most extreme version would be to have an intelligent reflecting surface that can only guide beams in a clever way. Finally, as highlighted, the 6G is not only about communications. We need to do ranging, sensing, localization in a very tight way to enable the Internet of Senses. So we are reusing sites in that way to get economy of scale to roll out these capabilities close to the users. We also need to bring in the mobile edge computing clouds in a very tight way and interact tightly with applications. This we need to do in a privacy conserving, trustworthy, and secure way. So tight integration is very important in an end-to-end architecture. So mobile communication is much more than radio parts nowadays. It's convergence of a lot of industries and sciences. So with that, a lot of fun research and engineering challenges. So if you are eager to find new paths in your career, welcome to join. And finally, I want to give a pitch on that I'm a local organizer of the European biggest conference on communication networking as part of the EU leadership of Sweden next year. So it will be in Gothenburg in June. Please join.
Thank you, Tommy. Thank you. So now please, all speakers, come up. We are a little bit after time, but we have some 10-15 minutes here for discussion. Yes. So first I have a question for each of you to start the discussion, and I start with you, Cecilia. We very often hear that everything should be connected to the internet, and at least in my home, there are a few things that are connected to the internet, but not the freezer and fridge and oven, etc. So when do you think we will see a new built home fully, where every electrical equipment is connected to the internet? And what will Ericsson's role be in reaching this point?
Well, I think Ericsson had a vision already 10 years ago about 50 billion connected devices. And I think a few things to be said on this one is that it always takes longer for things to happen than you believe, and once they then take off, it goes quicker. So again, before coming to your home, I said 75% of the traffic in the network is video, and we spoke about mobile TV and video so long before it happened, and then it suddenly, really took off. I think for the connected home, again, everything that would benefit from a connection will have one. I think this is also a matter of cost and having the price points right for people with a value. But if we move forward, maybe we could see this happening in 10 years or so. I think it has to go with the green transition. So I think there has to be other reasons for connecting everything, not just because it's fun to control it as well. And I think Ericsson's role there is in helping to drive the ecosystem. That you have things that are small and cheap and easy to connect.
Thank you.
Thanks.
And for you, Bengt, PTS are in charge of frequencies, among other things. And well, Tommy, on his pictures, he showed how we can use time, frequency, a lot of things to make the system's efficiency. But at the end, we need some frequency for radio communications. How do you think, will we run out of usable frequencies to fulfill all the needs and wishes we have for mobile communications in the future, or will there be enough?
You can say that every operator would like to have as much spectrum as possible. And every operator would like to have at least the same amount as the other operators. And then we have industries now also showing a growing interest for spectrum. So there is enormous demand. And the spectrum is allocated through market mechanism, auctions. So the one who pays the most. But this is just a small part of our spectrum. So auction is used as a mechanism to allocate spectrum. But you can say that a lot of spectrum is underutilized. So it is allocated, is on long term, maybe 25 years. So they have the right for these 25 years. And this is the way it goes. But in principle, a lot of spectrum is not used if you go outside city areas. So this means that the way we have done this, more like properties, that you have a lease, a long-term lease on this property. But what is going to happen is that we have to share spectrum much more. So you have to use this spectrum more intelligent, more dynamic use. And I think part of the 6G and also already 5G that we have to share spectrum. And spectrum sharing has been and is used a lot in Sweden as a network sharing, a radius. So in that respect, we have a limited, sort of, it's a scarce resource, but luckily here, Tommy and the researcher allow us to come further up, terahertz, even though it's like raindrops, so they're very sensitive to propagation there. But I would say that we have to use the spectrum that we have that is allocated and harmonized more intelligent, more dynamic. So that will happen, I think, so in order to use it more efficient, because the demand is enormous.
Okay, very good. Thank you. Now, Tommy, you represent the university, so I will ask another question to you. As Cecilia mentioned, we need a lot of engineers. And when I came to Chalmers in '93, if I remember correctly, we had some 120, 125 students in our first course on communication. But then over the years, it became fewer and fewer. And it was not only at Chalmers, but at all universities seem to have the problem that the interest from students to take communication courses decreased quite a lot, actually. So how is the situation right now, and what do you think we can do, if needed, to increase the students again to take courses in communication and contribute to this very, very challenging and interesting world of mobile communication?
Yes, I was coordinator of the master program for a couple of years, and the year I took over, it dropped from 95 students to 7 students. That was when we introduced the fees. So that lowered the attractiveness in Sweden. But then we are on stable level at 25-30 students nowadays over the years. When it comes to research, we are very attractive. So the group, as I mentioned, we are more 40 plus. I think there will be 12 more coming in next year, with maybe 40, 45 in the group. So 30 PhD students or so. Oh well, okay, maybe 20. So I think we are very attractive in that way. But I think the key is this convergence of the different sciences. It's not only as a marketing, because we really need it. We have holistic problems to solve, and that means holistic approaches. It means multidisciplinary competencies to be able to do things we want and to do it in a sustainable way. So I think that's the key. Communication is not an isolated part of an intelligent society. Digitalization goes very deep. And for digitalization, we need sensing, we need communications, we need decision algorithms and actuations, being humans automated. This loop is tied together. So the more educated, holistically, the engineers are for the future, the better system we can do. That becomes sustainable.
Thank you. Swedish universities are still very competent and good in research of mobile communications, but I think we, as you can see from the presentation, there is a need for many researchers. So we really all together have to help out and stimulate students to study in this very challenging and interesting area in order for Sweden to continue to be leading in this very important area for the future. So now we can open up for questions. Yes,
please.
We have done
one over here.
One over there, please.
Yes, my name is Stefan Mangold, and I was 1972, enjoyed Chalmers at Electro Technology. I'm very interested presentation of especially 6G. And my question is, how will it be with 6G? Will we be much more monitored, alltså övervakad, each person, than we are monitoring today?
Thank you, Stefan. Who want to answer that? Will there be much more monitoring?
I can start commenting. The enablers will enable it, yes. We will have sensing capabilities we already have in the phone. There are quite much sensors in the modern smartphones today. The access point will be able to sense. So the question is what we do with this sensing information and who controls it and who initiates the sensing process. I can take a good example. I had a dinner in the research center a couple of days ago where we talked about radar and the information from radars on vehicles, who owns it. An analogy, I think, is if I sit here and I look at you, I get information from you by seeing you. And that I use for whatever thinking I do here and now. But when we leave, the information is gone. I mean, the raw data is gone. I think it's a matter on how long time we store it. Whereas if I take a photo, we have GDPR aspects, because I can use it much later in another purpose. So I think we need to regulate how we use the information and limit to the source whenever that's needed.
I think that's an excellent answer. It's not the technology will be there. So it's about what norms and cultural values we put on it, and then what control mechanisms we put in place as well. So the more we think about these things in time, the better of a society we will be able to create. Because there are so many advantages when technology is managed in the right way. But we can't let the enabler control us. We need to control what we want to do with it. Thank you.
I think it's, with technology like the coin, there's always two sides, and one has to use them in a good and proper way, and we really have to hope that it's taken care of, so we don't end up with a society where everyone can see what we do all the time.
I can just add there that the regulation of data, who is controlling the data, what is happening with the data, these are issues already today where people have a growing concern. So the question of integrity, and as I said, cybersecurity, etc. These are huge issues for ongoing regulation in this area is in place, and as this system becomes even smarter, the question will be even bigger. So what my point was, technology, a lot is feasible, but do we want it? What do we do with it? And what are our concerns? This is a growing and big question, and if we don't accept it, this will not happen. So in that respect, there's an interplay between the regulation, the demand, and the technology. So this has to be socially acceptable, otherwise we have a problem.
Okay, we have another question here.
Yes, my name is Kent Erik Long. My question is, do you think that the speed of regulation in Europe will keep us in pace with US and Asia, so that we are efficient enough so that the industry can be in the lead?
Did you get that question?
Yes. I mean, you can say like this, if you look at mobile communication and communication in the United States, prices are higher, networks are not as good. And what they use 5G for today, like a Verizon, is primarily because they don't have fiber. So they use 5G instead of fiber. And then regulation, they love monopolies, and they are not as critical on the data protection, for example, as Europe. So, I mean, the regulation in Europe is trying to place as a human-centric, you can call it. But it's, in the same time, these are social and quite slow processes, as you say. And then when it comes to area here, it's a question of spectrum. A spectrum is on a global allocation, so then the whole globe is in the same pace. But there is also an aspect of this, that regulation takes time, because there are consequences and you intervene. Okay, what is negative and positive? So I would say on the data side, a lot of work has been done, but more will be done.
Yeah.
Okay, we have time for one more question.
Final from Dennis, from ABB.
Okay, then I will put a simple question, I think. Where do we stand today with the rollout of the 5G? And what is the learning from the 5G so we make the 6G go faster?
Yeah. So if we look to 5G today, 18% of the world's traffic is carried over 5G networks, but it's super big difference where in the world you look. So in South Korea, it's mainly 5G that carries the networks. In Sweden, for the first time ever, we are among the last to deploy among advanced countries. And the services used are still a lot of fixed wireless access, so that's a great factor that you can use 5G instead of fiber. But we are still in the early days of what we really want to happen, which is the advanced digitalization of industries. And I think that we had a great starting point when we started collaborating in Sweden here across companies and academia with Ericsson and Telia and others, but it hasn't really yet happened. So we are at an amazing, so while I take all this time to talk about 6G, we still have an amazing journey of 5G still to happen in front of us. Yeah, I can talk a lot more about that, but depends on what aspect. I think some of the things we're going to drive together with advanced digitalization now really needs to happen. There needs to be more money put into it. There needs to be more collaboration. And some of the objectives with the Advanced Digitalization Innovation Program that ABB, Ericsson, Saab, and with Vinnova is going to pave the way for a lot more to actually happen with 5G.
Okay. I think I have to cut there, if that's okay. We actually got our first YouTube question, so I will ask it quickly and then a quick answer. And it's a very Chalmersy question.
And this is a post-it one.
Yeah, a lot of innovation at Chalmers Electro has been driven by building complicated systems for Onsala Radio Space Observatory. What does the collaboration between Onsala and Chalmers mean today? Anyone who wants to answer that?
The collaboration between, I didn't catch what he said.
The Onsala Space Observatory has driven a lot of the fast frequency stuff. So anyone who wants to answer that? It's from the YouTube channel by the Algon is called.
I don't really, I'm not updated on the cooperation, but I think that what they do at Onsala is quite different what we do in the communication systems group. It's all about radio, but in two quite different ways. So at least during most of my time at Chalmers, we did not cooperate very much in that way. Tommy?
Yes, I think it's somewhat true, but I would say that Onsala and astronomy science is driving the hardware. And so the basic research is done to a big extent there. Now when we open up for sub-terahertz towards terahertz bands, that we do partly by building on what has been done in the astronomy-driven circuit research. Now when the mobile industry gets in there, there will be much more funding. So maybe we can pay back to that community by helping them with the terahertz circuitry solutions.
Well, I noticed the space dimension presented about 6G, so we'll look about that. Thank you so much, dear communication panel. Thank you, Anna. Thank you, Tommy. Thank you, Cecilia. Thank you, Ben. And we're ready for the next panel, so I will give the word to Linda Olofsson to present the panel. And you can do as they did or the previous panel sit here or sit whatever. Linda Olofsson, give her a big hand.
Thank you. My fellow presenters, I would like to welcome you up on stage and have a seat. Yes, please go ahead and sit. So, welcome to the electromobility session, and welcome our dear presenters. I would like to present you to all before we start. And with us, we have Dennis Helfridsson, Country Managing Director at ABB Sweden, and also Vice President and Local Business Manager for Robotics and Discrete Automation Businesses. And you have over 20 years with ABB, and I've learned that you are from Hallstahammar and has a passion for Swedish industry, diversity, and sustainability. Welcome. And we also have Anna Westberg, who is the President for Volvo Buses and member of the Volvo Group Management. And you joined Volvo in 2009, and since then you held several positions as Vice President and Senior Vice President and President of Volvo Group Venture Capital, for example. And I've learned that you are a Chalmers alumni with a passion for improving your customers' performance and thereby creating new business models for Volvo. Good for Volvo. And then we have Torbjörn Thieringer, who is a professor at Electrical Power Engineering here at Chalmers University of Technology. And you have worked with power engineering for the past 34 years at Chalmers. And you started with electrical engineering and made your way all the way to electrical vehicles and battery technologies via power electronics and electric power systems. And your passion is to work together with your students to create knowledge and to see them grow. It's wonderful. Yeah. Sounds like a wonderful teacher and supervisor, I'd say. And then we have also Evelina Wilkner, and you are a postdoc at Electrical Engineering at Chalmers University of Technology, and you work with lithium-ion and sodium-ion batteries with a focus on battery aging, understanding that, with different types of applications, and especially electromobility, I would say, yes. And you combine battery testing and test methods, and test method development with different types of battery models. And your passion is really batteries, I've learned. Yeah. But we have met in the gym sometimes, so I know you also have a passion for making muscles. So we have good muscles going into learning, understanding battery aging. That's good for this, this area, I would say. So, welcome. I would also like to say just a few words about myself. Linda Olofsson, I'm the director of Swedish Electromobility Center. I'm a physicist. I didn't study at Electro, but at engineering physics. I have an extensive experience and passion for leading and coordinating industrial partners and researchers to find common solutions to complex technical challenges, like within electromobility. So, now we are ready to start. And I took the opportunity to say that I wanted to talk a little bit about our center. It's been around since 2007. And Electro at Chalmers has been the host ever since. And the center has really followed the evolution of the area of electromobility, I would say. It was started by some people in 2007 who saw themselves as believers in the electrical motors. And at that time, there was not so many people who believed in electric motors, I was told. And then a lot of things happened. Tesla happened, and a tremendous development happened. And today, we see electromobility as a key solution to obtain sustainable transport. So it's a great journey for this center and for the area, I would say. I mean, now we have gone from from having 0 EVs to having only a few EVs sold every year. And now we're up to 60% of the new sales are electrified cars. And also, for the heavy vehicles, we had an inauguration of fast charging for trucks at Vädermotet just a few weeks ago. So it's very exciting things going on within the area. And then, just to tell you about Swedish Electromobility Center, it's a joint venture investing in e-mobility research. It's financed 1/3 from academia, 1/3 from industry, and 1/3 from the Swedish Energy Agency. It's a partnership of some 27 partners. And it's grown tremendously, like this area, the past couple of years. Our mission is to accelerate the development and the implementation of electric propulsion technologies into the transport ecosystems. And we do this by bringing academia and industry together within a range of different disciplines. We have experts from industry and experts from academia sitting together in theme groups, discussing what research we need to do, forming our strategic research areas. And then we finance projects based on these strategic needs for the area. The backbone of our center are 5 theme areas. And this center started, as I said, when we didn't really have the technology for having full-scale implementation of EVs. We only had like motors, but we could not make it like it is today. So we formed 3 theme areas that were centered around the vehicle, onboard system. Intelligent vehicles and systems is a theme area that looks into mathematical modeling of the system on board, the energy management system, how to optimize the energy management on board the vehicle to make the battery range longer and to optimize the charging for the battery and help the driver with route planning services. The second theme area is the electric drives and charging. And this is both theoretical but also hardware-wise. Here we look at how to improve the electrical driveline and how to build the hardware of the infrastructure needed for charging. We look at the electrical motor to make it more efficient, and I think that Torbjörn will tell us some more about that later on, so I'll not skip ahead there. And we also look at how to make our components last longer, how they can have a longer lifetime. How can we monitor the essential components of the system so that we can know when exactly to exchange them. The third theme area is energy storage. And here's both batteries and fuel cells. And important issues here is to address, like Evelina is working on, battery aging. And to learn how to handle the batteries in the application in the car or the vehicle. And we also look at safety to prevent, for example, fires with batteries. Now, during this time that with this tremendous development for the area, we realized that, okay, the technology on board the vehicle has matured. It's gone from being not something that we could really handle to something that we really can handle, or something that we actually can produce and put on the market. Then we need to look in a wider perspective. We need to understand how the users adopt to the technology, this new way of fueling, this new way, this specifics that the EV has in comparison to the old traditional fossil cars. And we also, because we claim that this is a good way to handle and to accomplish sustainable transport, we must make sure that the environmental impact is minimized. So we started our fourth theme area, environment and society, that addresses these questions. And then things were happening in our, the surrounding world, and we realized that we are not the only one looking into electrification as a way to obtain sustainability, but also the industry is looking into electrification for their production, etc. And we have this digitalization going on that also costs a lot of energy. So there will be a competition, and we have a challenge in the capacity of the grid. And so we started the vehicle-to-grid interaction theme. It's looking into the bottlenecks that we have with actually a growing fleet of electrified vehicles that wants to charge at their needs in order to function in a way that we expect them to function. So when, how, and when should we charge? This is our fifth theme area. Now, to solve this whole thing and to accelerate the implementation, we cannot just work in 5 separate theme areas. They must come together. We must work all the way from the components on theme 2 and theme 3 to the integration in the vehicle in theme 1, to the implementation, full-scale implementation of theme 4 and 5. And here, the information, the data, the possible solutions must be discussed and flow back and forth. And this is something that we do in the center via workshops, cross-thematic roadmaps talks, and project planning, etc. And before I conclude, I would just like to mention that we have 2 side activities in the center. And one is the PhD network, doctoral network. And if there are any PhD students here within electromobility that has not yet signed up, please do. It's free, and it's nice activities, team activities, lunch seminars, courses, and a very popular summer school. Then we also have a global watch on EV. And I'd like to cite our chief editor, Magnus Karlström. It gives key insights about research, policy, and market development of the global e-mobility landscape for Swedish stakeholders. So if you're interested, please sign up. And then also, if you want to take part of our activities and see what's going on within the center, we also have a newsletter on our website. Thank you. And then, I believe it's Anna. Welcome.
Thank you so much for that. And hello, everyone. Thank you. As you heard here, I'm from the Volvo Group, and I'm leading Volvo Buses since almost 2 years now. And it was very exciting also here to listen to your introduction, because I can confirm that all the focus areas of the center is of very, very high importance and relevance to us, and it's something that we speak about daily, these areas, for our future competitiveness. And Volvo Buses, we offer city buses, intercity buses, and tourist coaches, and various services for productivity, safety, efficiency, and financing. And we are part then, as most of you, I guess, know, of the Volvo Group, which is one of the largest providers of transport and infrastructure solutions in the world. And at the Volvo Group, I mean, here you can see the vision of Volvo Buses behind me, but at the Volvo Group, we are determined to fulfill our commitments to the Paris Agreement and to lead our industry in the transformation to net zero greenhouse gas emissions. And for us at Volvo Buses, this means that in 2030, half of all the buses that we sell will be electric. So in the Volvo Group now, since a couple of years back, we are intensifying and accelerating our efforts within electromobility and electrified transports. And we do that with our buses, as what I represent today, but also with our trucks and construction equipment. And we now have electric products in all of these areas, industrialized and out there in the market with customers. So we really want to be the true partners where cities around the world want to become more sustainable. And when we work with, for example, public transport systems around the world, we strive, of course, for zero emissions, zero noise, and all those advantages that come with electric buses. But it's also about taking sustainability for the whole solution and during the lifetime of the product. So we work with a true cradle-to-grave approach, which means that we have to make sure that materials, manufacturing, operation, and recycling of our products meet the highest environmental standards. And in addition to that, our batteries also have a second life. So when they have done their job in the electric bus, they can be used in another secondary application, for example, as energy storage in apartment buildings or in other stationary applications. And to be successful in this transition and to implement these type of systems in a city, because we call it the systems, we talk about integrated and complete solutions. And we also heard that when we talked about in the communication session before here about cross-industry collaboration, but also about partnerships and digitalization, and all of these areas is actually coming together when you want to implement a sustainable public transport system. So it's not only about the bus, it's about the charging equipment, it's about the training of the driver, it's about understanding how much energy you need to carry on board the bus, where to put the chargers. It's about other infrastructure, safety, connectivity, and many other things around that. So all these parts are critical in order to create an efficient, safe, reliable, and responsible public transport system. And to support cities then, to make this transition to electric buses, we have at Volvo Buses established a working method that really embrace this system perspective and cooperation based on partnerships for implementation of urban public transport. And for us, a very good example, since we're here in Gothenburg today, is the Electricity project, where we both had Chalmers as a partner, ABB, that is also represented here today, was a partner. That after that type of research pilot phase collaboration with many stakeholders led that we here in Gothenburg could make a large implementation, 150 electric buses, more or less implemented overnight in December 2020, which at the time marked one of the largest electric city buses implementations in Europe so far, and I would say it's still one of the largest in the Nordics. And from this work, we have gained a lot of valuable knowledge that we now bring with us when we go out and work with different cities around the world. Because very positive is that it's really happening now. I think someone talked about that. I think it was when we talked from Ericsson that, it can take time, and then it just happens, right? And what we can see when it comes to electric city buses, it's truly happening now. And it's happening in Santiago, Chile, it's happening in Brisbane in Australia, it's happened here already in Gothenburg, in Mexico City, etc. In many parts of the world, we are now working with customers, cities, and other stakeholders to make public transport more sustainable. So I'm very happy to be here and to take part of the continuing dialogue here today. Thank you.
See. So now it's your turn, Dennis. Welcome.
Thank you. So maybe this will be a little bit of a different speech because I think it's a celebration today, isn't it?
Yes.
And how many people are here have been study at Chalmers? Can I have a hand up? So we celebrate you today, and also the school. So I will actually think that in order to look forward, we also need to look back. Is that okay with you? Just one thumb up. Okay, then I will have a trouble today. Because today we are celebrating that Chalmers has its 120-year celebration here. And it happens actually that when Chalmers first stepped into the world of electricity and working with electro, it's also another company that also joined forces at that time, active in the same field. And it was the ASEA that later on became ABB. So we actually started pretty much at the same time. And it's also, as it happens, that Jonas Wenström, an engineer and innovator, he was introduced and invented a three-phase electrical power system, which also built ASEA. But also one of our most prominent figures in ABB is also coming from Chalmers. It's actually our CEO at that time, and later on also board of director, Sigfrid Egholm. He was graduated in 1891 here at Chalmers. Before he took over the ABB part, he actually was also electrifying the Gothenburg trams. So that's a little bit what we're coming from, and I see there's a lot of people, and unfortunately, you have me today. It was actually meant to be our CEO, who is also coming from Chalmers, Björn, who's going to stand here today, but I will try to make it fair. So, at that time in history, the electricity was still a novelty for most of the people. Even though, if you look at the statistic, electricity has actually been known just before 600 years before Christ. So electricity has been in that path for a long, long time. But until the end of the first half of the 19th century, electricity still puzzled a lot of physicists who struggles to make this to be a real act and to explain the behavior of the electromagnetic objects. What they didn't know at that time, what they were struggling with through the endeavors, was actually that the lay foundation of something that dramatically changed the economy and the social revolution of the history of the humankind. It's quite big words, isn't it? But when you look at these theories that came from this struggling, it laid based for several scientists, visionaries, and also entrepreneurs to put the science into use. We first then got lighting into the houses, the warmth into the houses, then later on to the industries and also to the whole cities. That maybe doesn't seem so big today, but it changed the whole world that we are living in. And after that, we see also that the electricity went over to trams, and also it follows up to what we heard today. We saw also that the communication part, the telegraph, the radio, and the telephone, and we heard also the mobile phone here. So electricity in this form has shaped a lot of things. Finally, I think also electricity was the base at that time for what we see also mass production. So the industry changed totally also at that time. The second industrial revolution, this not only changed the way of living, transporting, how we produced. It's also contributed to the transformation of Sweden and the Swedish economy. Sweden began its industrialization in the beginning of the 1800s, but it was not in the end of the century. Like innovative companies that put a lot of effort into this, like Ericsson, ABB, actually, Sweden took forward and also became the strong industry nation that we are today. We are now, today, right in front of a gigantic shift, the fourth industrial revolution, but also the transition to a fossil-free economy. E-mobility that we will talk about today is a large part of this. And it has also many similarities if we look at the introduction of electricity. Like electricity, it has taken more than a century, actually, since the first electric car was invented to now the technology take off. But also, like that in that time, with the electricity, the benefit of switching to electricity is also what we see today. We need to switch a whole system to actually manage this in the future. We have succeeded then, and I think we also will succeed now when it comes to this shift. So, I will just say 3 things that I would like to put and send to this team. Taking inspiration from the last 120 years of electrification, I think these 3 major parts will make a difference if we can manage them and master them in the right order. Firstly, this is actually a twofold challenge, but it's also a twofold opportunity. If society and business go hand in hand, we can also manage this challenge in the same time, and that will be much, much stronger. The second part is as simple as it sounds, and we were also in on that before, is actually how crucial it is. Because if you're looking at ABB, 140 years ago, was built by people. And still, people are the most important part of our company. And that is also why Chalmers is playing such an important role to make sure that we have the competences in these fields and these areas. We strongly need to see that the brightest and the best of the young people want and feel inspired to go into the science, into the careers in engineering, because that will be a competitive advantage. We will not like to stand to limit ourselves that we don't have the recruitment base that we want in the future. So it's absolutely crucial that we have these kind of universities that can help us provide this. But this, as we also see on these pictures, there's in many areas. We need more electricians, etc., because the electricity wave will also cover everything from maintenance to other things. The third thing is world-class innovation. Our competitiveness in ABB was built on innovation, and it's also the strongest force going forward to be in the top when it comes to innovation. Therefore, we put a lot of effort into research and development. But also our success is really dependent on our sparring partners' shape, and that's academia. And here also Chalmers plays an important role for us, because together we co-create a lot of things together, and we also get the people from them. So I would say that if that was the 3, I would also like to lift one thing, that we are unique in Sweden, I think, and at least in many countries, they are envying us. One of the most important things we have is collaboration. We collaborate between companies, academia, and if we would like to continue to have 120 more years of strong development and also expansion, we need to continue to collaborate. So, to conclude for me, 120 years ago, we were standing in front of a huge challenge. We managed that one. And I'm sure when it comes to e-mobility, we will manage that also and make sure that it creates business for Sweden, but also for the society. So thanks for that.
Thank you, Dennis. Let's see. Yes, now it's Evelina and Torbjörn. You will present your exciting research to us.
Thank you.
Thank you.
I'm not sure I can fulfill what you said about explaining everything, but it will be a short glimpse.
Excellent.
Yes. Okay, I thought you could hear me anyway. But so, as you heard, there are some driving forces in society that also affects us in our research. So if we start from the right here, there, yes. We want to create a 100% sustainable society in the future, and one of the tracks is the electrification of transport. But also we cannot forget that we also need to think of the cost. So this forms 3 things that we're working with, and energy density is very important. We need to have low losses and high efficiency, and that can create that we can have a high power density. High power density is about getting low losses, but also to not have the objects getting too warm. Now, this puts some topics for us or some tasks to work with. So of course, lower losses. Then we have an amount of materials that we actually would like to have a circling in once the product have been used. And now, in order to put this together, we need to have a good theory models, and that is both on the component level, but also a model on when we put components together to systems. Of course, we want to verify it experimentally, but the more we can do theoretically, the fewer rounds with experiments can be done. And then something really, really important is to understand the boundary conditions so that we can try to do something useful and reasonable. So here is an example. Here we have 3 electric machines. This is a part of the rotor. Here we have some strong magnets called neodymium bore magnets. We also tried another variant called samarium cobalt. And then also some cheaper and much more environmental friendly magnets called ferrites. And then we did 3 machines, and they were in principle the same size. But if we now look on the performance, here is the rotational speed of the machine. This becomes the vehicle speed after some gearing. Then we have the torque, the dashed lines here, and we have the power, which are the solid lines here. So we can see, as expected, if we have rare earth magnets, we can have the best performance. But it's not so much worse when we put ferrite magnets here. If we look on the upper curve, we can see the losses, but in terms of efficiency. So we can see that this red machine here is the ferrite magnets, and actually we also receive an area with 97% efficiency here. Actually, when we started, we thought that the magnets is the worst crook when it comes to environmental aspects, but actually it's the windings. If you have copper, you have a lot of pollution, so what we are hoping is to use more aluminum in the future. But as you all know, the resistivity is lower for copper, so therefore that has some great benefits. So, apart from theory models, we also need to verify our theories. And here you can see me when I did my master thesis work. That is back in 1988. So I finished a bit after that. And here is the drivetrain for the Volvo XC90, which we tested in our lab. Then we have measured a lot. I did a lot in my career measuring on wind turbines. Wind turbines are very similar to electric vehicles. And then we also have other activities, for instance, modeling of houses. And here we have an Epstein frame, single sheet tester that we do to check losses in materials. And the final slide. So, I said that it's important to have models both for component and for system models. Here again we have these beautiful curves from mechanical speed of the machine and output power. Those black dots here, those are the requirements coming from drive cycle and from product planning at the vehicle company, what the car vehicle should do. So then we have actually the same machine, but we have done it in little bit different sizes, from size 1 to size 2.3. But it's the same geometry, and they create these 5 curves. In order to drive these motors, we need an inverter. And if we have a really big machine, we can have a very small inverter, and then we have that red performance that actually seems to be the lowest. And then if we have a very small machine, we need a big inverter, and then we have this upper curve. So this means that we have a huge trade-off here to balance between losses and also sustainability. So this was what I thought I had time to say. Maybe I leave the word over directly to Evelina.
Yes, so now we're going on the other component. Okay. So that would be the battery. We need an energy storage. Let's see. So we work with both lithium-ion, and now we've also managed to start to work with sodium-ion batteries. So we do a lot of modeling. Different levels. We have empirical models, we have equivalent circuit-based model, and physics-based models. And the physics-based models is what I like the most, because that's where you try to mimic the physics and try to simulate the process that actually happens in the cell. So To find out what actually happens in the cell, we will have to do experiments. We do a lot of experiments, both characterization but also lifetime. As Linda said before, I work a lot on how the batteries are aging in different applications and different load cycles. And to do that, we have a lot of equipment. So here we have some versions of our equipment that we have in the lab. Those who had the lab tour got to see them live. But we also have equipment to open commercial cells and actually reuse the materials for lab cells so we can get a better understanding of the materials in those cells. We also have the applications. That's our goal, to see what battery works best in what application. So we have sizing of battery packs. We also important to understand that there is always losses, but how can we minimize these losses in the application? And we can do that by selecting different type of batteries. And we also then goes to the efficiency of the full system. It's not just a battery, it sits in another system, for example, in a vehicle, and it's the overall efficiency that is important. And then the last point here is just to connect back to where we started, the environmental footprint. That is very important. I mean, when we look at electric vehicles, the biggest chunk of environmental footprint comes from the battery, and we really need to improve this. We need to consider the materials, what amount of materials, and how we design these batteries to make a more sustainable selection. But also the production is important. So here we have a close cooperation where we can do life cycle assessments. And it's not us doing the life cycle assessments. We need some experts on that. So we have the Division of Environmental System Analysis doing those. But we cooperate on the other parts where we do good calculations on what are the materials that we have in different cells, different form factors, different shapes. And we can give that information to the environmental system people that can then make a production estimation for this life cycle assessment. What we can make an estimation based on physics-based simulation, what would be the losses, how would this battery behave? And we can put that into any type of model, but we need to make simplifications along this road, but still. We can put it in a vehicle model and get the losses during usage phase. And in this case, we can get a full life cycle assessment from the production to the usage phase as well. So that was the last thing I had to say, and now we go over to questions, I guess.
Well, I'll be happy to let you ask questions for Evelina in a moment. But first, I would like to address the whole panel with a few questions. And I'm going to start with competence, since we are at an excellent university. And this past couple of years, all I've heard is we can't find the right competence. It's so hard to find the right people for this area. And so my question is, how can we attract more students, more young talents to this area? For we really need it. Now companies are stealing each other's engineers at the moment. So we need to find young talents for this area. And maybe you, in the companies, do you have strategies for this?
I can start a little bit. I think it starts actually, I fully acknowledge that we have a challenge to find the right attractiveness for the industry, etc. But I think it's up to us also in the industry to make sure that we open up more, to show what actually a work today at Volvo or ABB actually look like. Because I had an open house now just a couple of weeks ago. We had an enormous amount of people wanted to come. It was 1,200 people entering that day just from their own employees for the robotics division. And we can see it when we bring the youngsters. I have fantastic pictures of them. They are so interested in girls and boys, etc. So it's up to us actually to attract them also. But then also I look into when it comes to the school system. And this, now maybe it's not just in this field, but for instance, today we actually have what they call syslöjd, we have träslöjd, but then we don't have kodslöjd. I was actually sitting with my sons a couple of weeks ago, actually, and asked them, they were talking about LAN, and everything around it. And then I actually asked, what is LAN? What is this? And they were like, we don't know. And I said, if you were able to build something, a game or whatever, would you do that? Yes, for sure. And then we actually started up together with university and Västerås to say that we need to find, because when we talked also to the teachers, they didn't feel comfortable to talk about digitalization, technology. So we also need to help them to get the right starting point from the first grade, the second grade, etc. So we are doing that together with that to make sure that we get it into the school system so they feel comfortable to talk about it. Because look at us, now here's a lot of good engineering, etc. But a lot of us is digital users. But when it comes to the technology behind it, then there's not so many that dares to speak up. So that's, I think, what we need to do. We need to also bring the interest in what's behind it. So that's my answer.
Yeah, I think you're spot on. We have to show how interesting it is, what an excellent job it is to be an engineer, especially within electromobility. To attract them. I mean, we're starting up all these new master programs within electromobility, but we need to find the engineers, the young people to go there. Yeah. Anna, do you have some?
I think you described it well. I mean, we have to start really early in the schools, but also, I mean, Gothenburg, it is an attractive city. I think we've also won many rewards, and we have industry here, which is world leading. So to continue to attract also students from outside Gothenburg, outside Sweden, I think that's very important. And the cooperation that we create exciting opportunities by close collaboration. So.
Thank you. Torbjörn and Evelina, do you have some?
I have nothing actually more than exactly what you say, that we have at each age. From I think you were also I'm thinking about this elevens val that the kids have when they are small. Perhaps students from Chalmers could get a couple of thousand kronas and show a teacher how to build an electric machine, something that is blinking, something that is sounding, and then keep on all the time to to show how interesting it is. Somebody mentioned about the number of students in the communication course. If you look, when I was a student, we were 240 students and 700 first applicants for the E-line. And now it's much fewer. So somehow, I mean, this is such an interesting theme, but we have totally failed to make people understand how interesting and important tasks there are here.
And
but
what
I
you
see
could work
Jörgen here, I think we are doing a lot also, but I don't know all the details, but that I've understood. But yes, obviously we must keep on trying more.
Must do more.
We must be,
Maybe I can go with a positive comment here that we have a battery course, and it's a big interest in that. So there is a lot of interest from different master programs, and the course is always fully booked when it starts.
That's very good news. Yeah, I think good news, and we all have to be ambassadors to attract young people to this area. And then my next question is, we have this challenge with the electrification, that electrification is not only seen as a key for sustainability in transport, but also within industry and the energy supply. We have already discussed that today. But I'm thinking, how do you think we can handle this in a good manner? And I'm thinking also because of the insecure world that we now are experiencing, that we have requirements on this transformation that we are doing. We are going from a transport system that's been around for 100 years, and for decades we have tested this transport system from different aspects quite harshly. And so we know about this transport system. It knows its limits and its capabilities, and we know how to handle it. And now we're going through this transformation in quite fast with a new transport system. How can we make this transport system reliable, robust, and resilient? How can we actually test it? to see that it's working, that we don't have the problems with energy supply, etc. And how can we think? Can we think strategies about this? I see you, Anna. Do you have? Yeah.
No, but I think when we have, I mean, a couple of years ago, we were like pioneers in this area in Europe. We had to convince cities to go electric, but today it's more convincing, go electric with Volvo. So when I touched on that, the system and integrated approach, I mean, if a city, let's say, in let's say a country, let's say Colombia, of course, first we will look at, okay, where do you get your energy from? Is it green energy, or where do you get the energy from? And then based on that also recommend, how would you start implementing an electric bus system? So it's really about that, taking that whole system overview, and you need to involve many stakeholders into that process as well, infrastructure providers, etc. And also what we hope, what we come from in our DNA. I mean, environment has been one of our core values from way back, and now we talk about sustainability. But to be true to that, to have this. I mean, you talked about the life cycle assessment, but that cradle to grave approach, and that what we develop can be fully also recyclable. Which our new electric chassis product, I'm very proud to say, it's over 90% recyclable. So it's, I think it's about that to build something that is responsible long term and not just here and now. I think that is what, and then many people need to come together and think about different angles and challenges around that. And I think here we have been very successful in our collaboration so far, here.
You mean Göteborg when you say here? Yes.
Yeah. Mm.
I can say something, because I think we actually, if you look at Sweden, I think we actually are quite, it's a good pace actually in building out the infrastructure with the chargers, etc. I think we have a challenge when it comes to make sure that every initiative actually gets the power supply as they want, because that's a little bit of a challenge. But I think we need to keep up the pace, you know, to make sure that, and I think the consumer here, we have decided we will shift. So I think when you decide to shift, we need to also to make it go along. But I think also one of the challenges is that we make sure that one of the biggest, you know, the heavy vehicle, maybe it just stands for 4% of the transportation, but it stands for a lot of the damage. And we need to find these big routes that we can have megawatt system to charge, etc., to find this way forward. So I would say it's a good path that we are on. At least. I don't know if you agree with me, but I think there's a lot of things happening.
A lot of things happening. When it comes to the infrastructure part outside, I mean, if we look at Europe, for example, it needs to accelerate, and we need much more charging points. We know exactly actually what we need, since we can look at the flows today of all the vehicles running in Europe. And as you might have heard, we have also, as Volvo Group, together with two of our competitors, formed a joint venture to invest in charging infrastructure also in Europe. And we hope that will be followed with similar alternative initiatives, etc. So it is key to think about that whole chain and what is needed in order, because the products we can do for sure, but it's the whole setup.
Thank you. I feel someone is behind my back here.
Thanks.
Do I have one more question or so?
Take one more. Yes.
Yeah. So I would like to address. I have, but I wanted to give Evelina. Oh, David share. Oh, excellent. Well, I wanted. I mean, the battery is like a core thing in electromobility, right? And the battery aging is so important to understand and learn. How can we avoid it? How can we make the battery live longer? And you are doing some interesting stuff there, Evelina, together with Torbjörn, of course. You have your latest article, Gender Aspect of Driving Style and Its Impact on Battery Aging. Would you like to just say a few words on your conclusions there?
Yes. So this was, to start with, it was about aggressive driving or calm driving. And then when we started to look at the data, we also started to realize that we know the gender of the driver. We have a lot of driving data, so that's kind of where it started. but rest assured, the most gentle, but also the most aggressive drivers, they were men. So that's a very extreme group. They are the extreme in both ends. But when it comes then to the battery aging, we were looking on, we know that if you increase the current, the discharge current, you typically age the battery a little bit faster. But we were also looking at what the amplitudes, when you accelerate, you have these spikes in current. How does these impact the aging? And we could see that for one of the cells we tested, it did age the cell a bit faster. But for one cell, it actually didn't show any big difference. So it was quite interesting.
And will you move on to do further studies?
Probably, but we have no project planned yet.
Okay, thank you. And now?
Okay, I have a question maybe from our digital platform. What are the particular set of skills that companies are looking for while hiring within electric drive systems?
Yeah, many of them. I think we have candidates here that work in many different areas that are very, very relevant and interesting. So understanding how the battery ages in different applications, and so the life length, durability, also the energy efficiency. Of course, it's extremely. I mean, today we are experts in knowing exactly the fuel consumptions, etc., from our internal combustion engines, but we need to be as good with our, we call it ESS, electrical storage systems. So it's but it's basically a lot about the battery. But so in those areas, it's absolutely critical for the competitiveness.
It's easy to have a follow-up question about that. What kind of electrolytes are we going to use in the future?
I pass that to the experts here. Well, I would say that depends on the battery that you will use. So I cannot give a good answer there. So based on the lithium-ion battery, I think we still will have the similar electrolytes that we have today, but hopefully they will come with a more safer electrolytes.
All right, we're on overtime, but we have a few more. One up there, please.
I'm a student from Electro Chalmers in 1962, and my name is Lars. I would like the panel to comment not anymore on the use of batteries, but at least some on the use of fuel cells powered by hydrogen.
Yes.
Was the question if we are looking on it, or if
to me, heavy battery packs in electromobile mobility is not the end solution.
Okay.
I think that hydrogen and fuel cells could make a great difference. Please comment.
Yep. Sorry, but I can comfort you. This is also on an agenda. Actually, a project we started very recently with an industrial PhD student from AB Volvo. So there we're going to look into using a fuel cell with a smaller battery with a high power density, so that it's less losses. And we will also have a vehicle with a energy optimized battery. And also we actually have an internal project also looking into, should we use, if we have hydrogen, should we bring that to power station, send electricity and charge into vehicles, or should we fill the fuel, the hydrogen directly into the vehicle? But yes, I do agree. It seems very logical that the fuel cell would be great, and exactly as Evelina said, the smaller the battery, the better. Oh, you didn't say that, but any comments?
I can also comment on that. For our coaches that go long range, and also for heavy duty trucks long range, we are also of course looking into, as you said, fuel cell battery electric solutions. And here we have also formed a joint venture with one of our top competitors, Daimler Trucks, with a company called Cellcentric, to develop that fuel cell technology together, but for others to use as well. So very exciting, but different alternatives to be used.
I can also comment, I mean, there's sort of a little battle between systems here. We're looking into mega fast chargers, fast charging and megawatt charging. And we're looking into dynamic charging with electric roads, and then you also have the hydrogen. So there are several ways that you could make the long haul logistics works, and it hasn't really worked out which way we will go, but right now hydrogen and fuel cells are quite hot, I would say.
Most ununderstandable that the electromobility vehicle is dragging around hundreds of kilos of batteries for the energy supply. Hydrogen would make a terrific difference. Why does it take so long?
I mean, I think it's all about the infrastructure and the access for that. It's not there as well. And I think for many applications, definitely just battery electric is also the highest efficiency and the best solution. But as you say, for those longer, heavier applications, we believe in fuel cell battery electric solutions.
Maybe I have a comment here then also that right now hydrogen is made often from fossil fuels anyway.
Exactly. Brown.
But the more wind power and the solar power we will get, the more surplus energy can be used to produce the fossil-free hydrogen. So, but I think things, it was said several times that it seems obvious, but nothing happens, and then it will happen. So, to comfort you, we all believe in hydrogen, and we think it will come.
Yeah, and I think Anna's
no, but
right
it's important
with
what you said with the green hydrogen. I think that's very important.
Yeah.
And maybe I also should comment on the weight. I think that it's important also to look at the full weight of the vehicle. And yes, the batteries will be heavy, but if we can slim down the weight in other parts of the vehicle, we can still make a decent weighing vehicle and not a super heavy vehicle. Yeah.
All right. Do you have any more questions? We're on overtime, big time.
Sorry, I will try to keep this short. Just a very quick comment on your question. There are actually technologies where the battery is used for structural support of the vehicle as well, and then it wouldn't just be additional weight, it would actually be part of the frame of the vehicle itself. So I mean, there are some technologies coming that will help with this. I had a question of my own as well. It's for Torbjörn and Evelina, I think, mostly. Both of you work on electric drives and batteries, and these use materials that are sometimes not super abundant. You mentioned neodymium, for example, in the electric drives. So my question is, do you see a risk that we don't have enough materials for global widespread adoption of electric vehicles? And if there is such a risk, is there something that we can do about it? I know that you mentioned ferrite, which is iron, which is obviously much more abundant, but can you elaborate a little bit on that?
I start because it's easy. I think regarding electric machines, we have no problem because we can actually build a machine just with aluminum and steel, and that we have an abundance of. Then I leave Evelina to comment on the battery materials.
Yes, so there is always a risk when you use not so abundant materials, but we see that there is other battery technologies also coming, such as the sodium-ion batteries, and they are made of abundant materials. So there you don't see the same problems. And still, even if they say that the lithium is limited, there is still quite a lot of lithium left. And also for other materials, there is a mining problem, but you can mine these materials more sustainable. And that's where we should focus a lot of attention.
Do you see a risk with where you can find lithium? Because some of these places are not always super politically stable.
Yes, so that's also a problem, but I don't think lithium is the main problem there. We have cobalt, that is a big black wolf, so to say. But then again, if you go into other chemistries, you don't have cobalt in them. So there is ways around this. And other battery technology is also one of them.
Thank you. So maybe an important final comment is that, yes, there are other routes, but will lead to bigger, heavier, and maybe less efficient components. But I think if it's needed, it will happen.
All right, one final question. Yes, sir. Now it does. Can we get some microphone? No?
Maybe
I can tell you loudly. I do really agree with the part of fuel cells. And fuel cells can also be reversed. So you can use it for hybrid production and consumer of energy. So that thing that you can sell energy with fuel cells in form of hydrogen. And in Germany and more in Europe, they are more talking about fuel cells and batteries in cars than what we do here in Sweden. Here it's only batteries, and I don't think it's a good solution.
Okay.
I think I can comment on
any comments to that? That's more of a claim, so do you want to comment that? Yes?
Well, my first comment is that Germany has a totally different infrastructure for gas than we do in Sweden. So it's obviously much easier for them to base on fuel cells. We are behind when it comes to infrastructure for hydrogen.
All right.
Yeah, maybe don't be so sad. I think it will come. And I don't know if you ever have seen, there is a house in Angered that actually works according to this principle. In the summer, he has solar panel. Hans-Olof Nilsson is the enthusiast, and it operates exactly as you say. But in Sweden right now, we have this wonderful thing called hydropower also. So that means that we have a really good round-trip efficiency. A problem with fuel cells is that you get perhaps only 30% left from the electricity you put in. But that doesn't stop us. I think it will happen. So don't feel so sad.
All right, that will...
We're all happy. That concludes this section very well.
Thank you. Just give me a minute and I will thank you, okay? So thank you so much for coming. We are actually celebrating that we have had electric stuff at Chalmers for 120 years, which, thank you, Dennis, you so well gave us the history about. It feels very long back, 120. To be honest, we felt that it's going to be really, really cool today to talk about these things too, and it was. There's a few big takeaways. One about need for competence, need to go inside to the technology so we can attract more competence. Of course, Chalmers listens to this. It's really important, and we want to collaborate around that. The second word, which many of our dear panelists talks about, is that these are complex things. We need to collaborate, collaborate, and collaborate. And I hear us actually doing that a lot. So I'm really happy and hopeful, which is a word that also came a lot around during this afternoon. Last but not least, I really was so happy about the ability to look into the future, being especially our researchers, but also people from industry. That's what we are supposed to do. We're looking into a sustainable future. We're creating that sustainable future. And the word electro is right in the middle of that future. So, you know, you guys on stage today really, I think, instilled a lot of hope, at least for me and for many of us in this room. Thank you all, dear Chalmers and other friends, for coming. Also, you guys on YouTube, thank you for being there. This is something we want to do more of. We are very inspired to have had fantastic guests, almost too many because they didn't get much time, did they? They could have talked much more, but you know, we want to interact. So with that, Linda, thank you so much for keeping up the speed and interest in the biggest of the panels, which contain Evelina, Torbjörn, Anna, and Dennis, doing a great ending job, which means that before you give any applause to them, I'm going to say there's a mingle out there where we will have some cake because it's actually a birthday, 120 years old. That's a really nice age. Those who care about other drinks, there's GI Prips, the pub around the corner. We've booked the top floor. You walk up the stairs, and if you want to mingle with some other drink, you can do that as well. It's open. Now, with that, I would say hip, hip, hooray for Electro at Chalmers. May it live. 1, 2, 3. Hooray! 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 Thank you, panel, and thank you, Linda. And thank you, everyone who come and contributed. See you soon again.
Ja, tack själv.
Vi ses.
Ja. Var jätte...